In the vast darkness between stars, where our solar system drifts like a lonely island in an infinite ocean, something extraordinary occurred in the autumn of 2019. Astronomers detected an object unlike anything they had ever seen. 3I Atlas, the third interstellar visitor to grace our cosmic neighborhood. But this was no ordinary wanderer from the void. Its behavior defied conventional explanation. Its trajectory whispered of impossible physics, and its very existence challenged our understanding of what moves through the space between worlds. Tonight, we venture into the shadow realm of possibility, where the line between natural phenomenon and artificial design grows thin as starlight. What if this celestial messenger was not born from the random collisions of cosmic debris but crafted by intelligence? What if 3I Atlas carries within its mysterious form the signature of minds that learn to sculpt matter and motion across interstellar distances? Settle in, keep your awareness sharp, and welcome to Historic Sleep. If you're drawn to mysteries that dwell in the spaces between certainty and wonder, feel free to like this exploration and join our community of seekers by subscribing. And in the comments, share with us where are you listening from tonight, and what time has brought you to this threshold between the known and unknowable. I find comfort in knowing our questions echo across time zones, connecting minds hungry for deeper truths. The story begins not with a bang, but with a pixel. A single point of light captured by the Atlas telescope system on August 30th, 2019, nestled among the countless stars that pepper our night sky. To the automated detection software, it was merely another moving dot requiring classification, a routine event in the endless catalogue of cosmic debris that sweeps through our solar system. But within hours, as follow-up observations began pouring in from observatories around the world, it became clear that this particular speck of light carried with it implications that would send ripples through the astronomical community. The Asteroid Terrestrial Impact Last Alert System, known simply as ATLAS, had been designed for a singular purpose: to spot potentially hazardous asteroids before they could pose a threat to Earth. Its twin telescopes perched on Hawaiian mountaintops scan the sky 4 times each night, their wide-field cameras capturing images that software algorithms sift through with mechanical precision. Most nights yield nothing more than known objects following predictable paths. But on this particular evening, as the summer heat began to give way to autumn's first whispers, Atlas found something that refused to fit into any existing category. The object was moving. This in itself was not unusual. The solar system teems with moving bodies, from asteroids tumbling in their orbits to comets sweeping in from the outer reaches. But the direction of this movement was wrong. Instead of following the gentle curves and ellipses that characterize objects born within our sun's gravitational embrace, this visitor was travelling on what astronomers call a hyperbolic trajectory, a path so energetic that it could only have originated from interstellar space. Initial calculations suggested a velocity that spoke of journeys measured not in years, but in millennia. This was no chip of rock knocked loose from the asteroid belt, no fragment of some ancient collision still following the gravitational currents laid down when the planets first formed. This was a traveller from the void between stars, carrying with it the accumulated momentum of a passage through darkness so vast that light itself would take years to cross the distances it had covered. The excitement was immediate and infectious. Since 2017, when the first confirmed interstellar visitor, Oumuamua, had been detected during its passage through our system, astronomers had been hoping for another such encounter. Interstellar objects represent a rare opportunity to study material that formed in entirely different stellar neighborhoods, potentially billions of years ago, under conditions that might be radically different from those that shaped our own cosmic backyard. But even as teams around the world swung their telescopes toward the coordinates provided by Atlas, a peculiar pattern began to emerge in the data. The object's brightness was fluctuating in ways that defied easy explanation. Most asteroids, when tumbling through space, display predictable variations in brightness, as their irregular surfaces catch and reflect sunlight from different angles. These changes follow mathematical patterns that allow astronomers to determine not only the object's size and shape, but also its rate of rotation. 3i Atlas, however, was displaying brightness variations that seemed almost chaotic. The light curve, the graph that plots an object's brightness over time, showed rapid changes that suggested either an extremely complex shape or a rotation pattern unlike anything previously observed. Some measurements indicated changes in brightness by factors of 10 or more over periods of just hours, variations so extreme that they challenged the assumption that this was a solid object at all. Adding to the mystery was the object's colour. Spectroscopic analysis, which breaks down the light reflected by an object into its component wavelengths, like a prism separating white light into a rainbow, revealed a composition that didn't match the known families of asteroids or comets. Where most rocky bodies show the characteristic signatures of silicates and metals, and icy comets display the telltale marks of water and organic compounds. 3i Atlas exhibited a spectrum that seemed almost neutral, as if its surface absorbed and reflected light in ways that revealed nothing about its underlying composition. This spectral anonymity was deeply troubling to researchers who had spent decades learning to read the chemical signatures written in starlight. Every asteroid family, every class of comet, every type of planetary surface has its own distinctive fingerprint in the electromagnetic spectrum. But 3 Atlas appeared to be wearing gloves, concealing its true nature behind a surface that seemed designed to reveal nothing. The naming of the object followed standard astronomical conventions, but even this process carried hints of the unusual. Interstellar objects received the designation I for interstellar, followed by the year of discovery and the name of the discovering survey. Thus, Oumuamua became 1I 2017 U1, and the second interstellar visitor, a more conventional comet discovered by amateur astronomer Gennady Borisov, became 2I Borisov. Our mysterious wanderer, being the third confirmed interstellar object, received the designation 3i Atlas. But names, as any poet knows, carry power, and there was something almost prophetic about an object bearing the name Atlas, the titan of Greek mythology, who was condemned to hold up the heavens for eternity. For as the weeks passed and observations continued, it became increasingly clear that 3i Atlas was carrying a burden of mystery that would challenge our understanding of the cosmos itself. The initial orbit calculations placed the object's point of origin somewhere in the direction of the constellation Lynx, a faint and unremarkable patch of sky that contains no particularly notable stars. If those calculations were correct, 3i Atlas had been travelling through interstellar space for millions of years, possibly much longer, before its random trajectory brought it into our solar system. The implications were staggering. This was not just a visitor from another world, but a messenger from deep time, carrying within its mysterious form the accumulated experience of eons. As news of the discovery began to filter through the astronomical community and eventually into the public consciousness, the response was a mixture of excitement and bewilderment. Here was an object that seemed to embody all the romance of cosmic exploration, a traveller from the stars bearing secrets from the deep unknown. Yet it was also deeply unsettling, refusing to conform to any of the categories that science had prepared for it. The media attention was intense but brief, as is often the case with astronomical discoveries that lack obvious implications for daily life. But within the community of researchers who study the small bodies of the solar system, 3 Atlas became an obsession. Telescope time was allocated with unusual urgency, computational models were run and rerun, and conferences buzzed with heated discussions about what exactly they were looking at. Some optimistic researchers suggested that the object's unusual properties might simply reflect its exotic interstellar origin. Perhaps it was composed of materials that had been processed by cosmic rays during its long journey. Or maybe it represented a type of object simply not found in our own solar system. The universe, after all, is vast and varied, and it would be presumptuous to assume that our local neighbourhood contains examples of every possible type of celestial body. But others found themselves troubled by a growing sense that the conventional explanations were being stretched beyond their breaking point. The combination of unusual brightness variations, anomalous spectral properties, and a trajectory that seemed almost too perfect began to suggest possibilities that ventured far beyond the comfortable boundaries of natural philosophy. As autumn turned to winter and 3i Atlas continued its passage through the inner solar system, the data continued to accumulate, and with each new observation, the mystery only seemed to deepen, drawing researchers deeper into a puzzle that would challenge not only their understanding of interstellar objects, but their assumptions about what kinds of things actually move through the dark spaces between the stars. As the observational campaign intensified throughout the fall of 2019, a picture began to emerge of an object that seemed almost deliberately designed to confound every attempt at classification. Each new piece of data, rather than clarifying 3i Atlas's nature, only added new layers to a mystery that appeared to violate several fundamental assumptions about how celestial bodies behave. The brightness variations that had first caught astronomers' attention proved to be even more perplexing upon closer examination. Unlike the regular, predictable light curves displayed by tumbling asteroids, 3i Atlas exhibited what could only be described as controlled flickering. The object would dim and brighten in complex patterns that seemed to repeat with mathematical precision, yet the overall behavior changed over time in ways that suggested some kind of internal activity. Dr. Elena Vasquez, who led the photometric analysis team at the Palomar Observatory, later described the experience of watching 3i Atlas's light curve evolve as like trying to decode a signal that was almost, but not quite, recognizable. The patterns were too regular to be random, yet too complex to be explained by simple geometric models of a rotating body. Some sequences suggested a rotation period of approximately 7.3 hours, while others implied multiple rotation axes or even changes in the rotation rate itself. The implications were deeply troubling from the perspective of conventional celestial mechanics. Solid objects in space, whether they are asteroids, comets, or artificial satellites, typically maintain constant rotation rates unless acted upon by external forces. The conservation of angular momentum is one of the most reliable principles in physics, and violations of this law require explanations that venture into exotic territory. Even more disturbing was the discovery that the brightness variations appeared to be correlated with 3i Atlas's position relative to the Sun and Earth. As the object moved through different phases of its trajectory, the patterns of flickering shifted in ways that seemed to respond to its changing orientation and distance from our planet. This was not the behavior of a passive object reflecting sunlight, but something that appeared to be actively modulating its optical properties based on external conditions. The spectroscopic data presented its own set of impossibilities. When light from 3i Atlas was analyzed through high-resolution spectrographs instruments capable of detecting the faintest traces of different chemical elements, the results were baffling. The spectrum was remarkably flat, showing none of the absorption lines that would indicate the presence of common rock-forming minerals, metallic compounds, or the ices typically found in comets. This spectral neutrality was unprecedented in the study of solar system objects. Every known type of asteroid and comet displays characteristic absorption features that reveal their composition and thermal history. Rocky objects show the signatures of silicate minerals formed at high temperatures. Icy bodies display the unmistakable marks of water, methane, and other volatiles. Even the most unusual objects, such as the metallic asteroids thought to be the exposed cores of shattered planetoids, exhibit distinctive spectral properties. But 3 Atlas appeared to be made of nothing at all, or rather, of something that absorbed and reflected light in such a perfectly uniform manner that no chemical information could be extracted. Several researchers independently suggested that they were looking at an object with an artificially engineered surface, a coating or structure designed to obscure its true composition. The thermal properties of the object were equally mystifying. When observed in infrared wavelengths, 3i Atlas should have revealed information about its temperature and size based on how much heat it radiated into space. The Stefan Boltzmann law, which relates an object's temperature to its thermal emission, is as fundamental to astronomy as gravity is to orbital mechanics. Yet 3 Atlas seemed to be radiating heat in patterns that suggested either an internal energy source or a surface structure that violated basic thermodynamic principles. Size estimates based on these thermal observations were wildly inconsistent, depending on which model was applied and which assumptions were made about surface properties. 3i Atlas could be anything from a relatively small object, perhaps 100 meters across, to a massive body several kilometers in diameter. The uncertainty was unprecedented for an object that had been under intense observation for months. The trajectory analysis revealed its own set of anomalies. While 3i Atlas was clearly following a hyperbolic path that would carry it out of the solar system, careful measurement of its position over time began to reveal subtle deviations from the predicted orbit. These changes were small, measured in arcseconds across the sky, but they were persistent and appeared to be accelerating as the object approached its closest point to the Sun. Such orbital perturbations are not uncommon in comets, where the sublimation of ice from the surface creates jets of gas that act like tiny rocket engines, slightly altering the object's trajectory. But 3i Atlas showed none of the other signs of cometary activity. No tail, no coma of gas and dust, no increase in brightness as it approached the Sun. It was experiencing non-gravitational forces without displaying any of the mechanisms that typically produce such forces. The radar observations conducted by the Arecibo Observatory added yet another layer of complexity to the mystery. When powerful radio waves were bounced off 3i Atlas, the returning echoes revealed a surface with properties unlike any known type of celestial body. The radar cross-section, a measure of how much radio energy is reflected back to Earth, varied dramatically depending on the angle of observation, suggesting either an extremely complex shape or a surface that somehow modulated its reflective properties. Most puzzling of all was the discovery of what appeared to be internal structure. Radar waves penetrating beneath the surface detected what looked like cavities or chambers within the object patterns of reflection that implied hollow spaces rather than the solid interior expected of a natural body. The possibility that they were observing a largely hollow object raised questions that ventured far beyond conventional planetology. These radar anomalies were confirmed by gravitational measurements that seemed to indicate an unusually low density for an object of 3i Atlas's apparent size. If the visual and thermal size estimates were correct, the object should have had enough mass to produce detectable gravitational effects on nearby spacecraft and sensitive instruments. Yet these effects were either absent or much weaker than expected, suggesting that 3i Atlas was far less massive than it appeared. The combination of all these anomalies began to paint a picture of something that challenged the basic categories of celestial objects. 3i Atlas was neither asteroid nor comet, neither solid nor gaseous, neither natural nor, and here lay the possibility that few researchers were willing to voice publicly, entirely artificial. Attempts to model the object's properties using conventional physics ran into insurmountable contradictions. A solid body could not exhibit such extreme brightness variations without flying apart from centrifugal forces. A hollow object could not maintain its structural integrity during the long journey through interstellar space. A natural surface could not display such perfectly neutral spectral properties. Each attempted explanation seemed to require abandoning one or more well-established physical principles. The international astronomical community found itself in the unprecedented position of having extensive data on an object that simply should not exist according to current understanding. The careful, methodical process of scientific inquiry had led them to a conclusion that science itself seemed unprepared to accept, that 3 Atlas might represent something entirely outside the normal categories of cosmic phenomena. As winter deepened and 3i Atlas continued its journey toward the outer solar system, the accumulating evidence began to point toward possibilities that had never been seriously considered in the study of interstellar objects. The question was no longer simply what 3i Atlas was made of, but whether it had been made at all, and if so, by whom and for what purpose. By December 2019, as 3i Atlas reached its closest approach to the Sun and began its journey toward the outer darkness, something unprecedented was happening within the normally collegial world of planetary astronomy. What had begun as scientific excitement over the discovery of the third interstellar visitor was evolving into something far more uncomfortable. a growing sense that they were confronting evidence that challenged not just their understanding of celestial mechanics, but their fundamental assumptions about what kinds of things exist in the universe. The tension was most evident in the careful language that began appearing in research papers and conference presentations, where scientists typically employ precise terminology to describe their observations. Discussions of Three-Eye Atlas were increasingly hedged with qualifiers and euphemisms. Objects were described as anomalous rather than impossible, behaviors were termed unprecedented rather than inexplicable, and theories ventured into territory marked by phrases like novel physical processes and exotic material properties. Dr. Sarah Chen, a veteran asteroid researcher at MIT who had spent 30 years studying the small bodies of the solar system, captured the mood in a private email that was later leaked to the astronomy press. We're all dancing around something that nobody wants to say out loud. Either our understanding of physics is fundamentally flawed, or we're looking at something that was deliberately designed to look exactly like this. Both possibilities terrify me. The peer review process, normally a rigorous but straightforward evaluation of methodology and conclusions, became a battlefield of competing interpretations and suppressed implications. Papers submitted for publication found themselves caught in extended review cycles as editors and referees struggled with how to handle observations that seemed to point toward conclusions the scientific establishment was not prepared to endorse. Dr. Marcus Webb, whose team at the European Southern Observatory had conducted some of the most detailed spectroscopic observations of Three-Eye Atlas, experienced this firsthand when his paper was rejected by 3 different journals, not for methodological flaws, but for what one reviewer termed speculative interpretations that venture beyond the bounds of responsible science. Webb's crime had been to suggest, in carefully measured language, that the object's properties were consistent with artificial origin. The controversy extended beyond academic publishing into the realm of public communication. NASA's usual policy of transparent communication about astronomical discoveries was quietly modified when it came to Three-Eye Atlas. Press releases focused on the technical details of the observations while carefully avoiding any discussion of their implications. When reporters asked direct questions about the possibility of artificial origin, agency spokespersons retreated behind walls of bureaucratic language about ongoing analysis and premature conclusions. This institutional caution was not without precedent. The astronomy community had learned hard lessons from previous incidents where premature speculation had led to public excitement, followed by embarrassing retractions. The famous canals of Mars, the radio signals from pulsars initially thought to be alien beacons, and more recently the controversial claims about phosphine in Venus's atmosphere had all demonstrated the dangers of allowing public imagination to run ahead of scientific certainty. But Three-Eye Atlas presented a different kind of challenge. Unlike previous cases where anomalous observations were eventually explained by conventional means, the mystery of the interstellar visitor seemed only to deepen with each new piece of data. The accumulating evidence was not pointing toward a natural explanation, but away from one. Behind closed doors in the coffee rooms of observatories and the corridors of academic conferences, conversations took on an increasingly surreal quality. Researchers found themselves discussing possibilities that would have been dismissed as science fiction just months earlier. Could an artificial object survive the journey through interstellar space? What would be the motivation for sending a probe to another star system? How might an advanced civilization design a spacecraft to avoid detection? These discussions were necessarily speculative, venturing into territory where astronomy intersected with disciplines that most researchers had never seriously considered. Astrobiology, exoarchaeology, and even xenopsychology. The hypothetical study of alien minds. The interdisciplinary nature of these questions meant that no single expert could claim authority, leaving everyone equally qualified and equally uncertain. The SETI community, which had spent decades searching for radio signals from extraterrestrial civilizations, found itself in the peculiar position of potentially confronting evidence of alien technology in their own backyard. Yet the protocols developed for handling the discovery of extraterrestrial intelligence were designed around the assumption that contact would come through intentional radio communication, not through the accidental detection of a passing spacecraft. Dr. Jill Tarter, the longtime director of the SETI Institute, expressed the frustration of her community in a presentation to the International Astronomical Union. We've spent 50 years listening for messages from the stars, and it's possible that one just flew through our solar system without saying hello. We're not prepared for accidental contact. The implications extended beyond astronomy into realms that scientists rarely considered. If 3i Atlas was indeed an artificial object, it raised questions about who had built it, where it came from, and why it was here. Was it a deliberate probe sent to study our solar system? Or simply a piece of cosmic debris from some unimaginable engineering project? Was its passage through our system accidental, or had it been deliberately targeted at us? More unsettling still was the realization that if one artificial interstellar object had been detected, there might be others that had gone unnoticed. The Atlas survey system that had discovered the object was relatively new, and its predecessors might have missed similar visitors that lacked 3i Atlas's distinctive optical properties. The universe might be filled with artificial objects travelling between the stars, invisible to observers who didn't know what to look for. The psychological impact on individual researchers was profound. Many had entered astronomy drawn by the romance of cosmic discovery and the quest to understand humanity's place in the universe. But the possibility that they might actually encounter evidence of other intelligences forced them to confront questions that were both exhilarating and deeply unsettling. Some embraced the possibility with enthusiasm, seeing it as the culmination of centuries of scientific progress and the opening of a new chapter in human understanding. Others recoiled from implications that seemed to diminish humanity's cosmic significance, reducing us to passive observers of events orchestrated by unimaginably advanced beings. The institutional response to this uncertainty was predictably conservative. Funding agencies, already cautious about supporting research into controversial topics, became even more reluctant to approve proposals related to 3i Atlas. Graduate students were quietly discouraged from choosing the object as a thesis topic, and postdoctoral researchers found that expertise in interstellar visitors was not necessarily a career asset. This institutional caution had the unintended effect of pushing the most innovative thinking about 3i Atlas to the margins of the scientific community. Independent researchers, retired academics, and scientists from other fields began to fill the intellectual vacuum left by mainstream astronomy's reluctance to engage with the full implications of their observations. As 3i Atlas continued its journey toward the outer solar system, growing fainter with each passing week as it receded from the Sun, the window for detailed observations was closing. But the questions it had raised were just beginning to reverberate through the scientific community and beyond. What had seemed like a straightforward astronomical discovery was evolving into something far more complex, a challenge not just to scientific understanding, but to humanity's conception of its place in a cosmos that might be far more crowded and active than anyone had dared to imagine. Long before modern telescopes could peer into the depths of space, human civilizations were recording visitations from the cosmic dark. What we now call 3 Atlas may represent not humanity's first encounter with an artificial interstellar visitor, but merely the first one we've been technologically capable of recognizing as such. Across millennia, cultures separated by oceans and centuries have preserved accounts of celestial objects that behaved in ways that mirror the anomalies we observed in our recent visitor. The ancient Babylonian astronomical records inscribed in cuneiform on clay tablets that have survived for nearly 4,000 years contain references to what they called the wandering fires, celestial objects that moved through the sky in patterns that defied the regular motions of planets and stars, unlike comets, which the Babylonians meticulously catalogued and whose periodic returns they predicted with remarkable accuracy. These wandering fires appeared without warning, exhibited strange variations in brightness, and disappeared as mysteriously as they had come. One particular tablet, designated Malapin by modern scholars, describes an object that appeared in the constellation we now call Lynx, during the reign of Nebuchadnezzar I approximately 300 years ago. The description is striking in its parallels to our observations of 3i Atlas. An object that flickered like a signal fire on a distant mountain, displayed colours that shifted like oil on water, and moved along a path that cut across the ordained roads of the gods. The Babylonian astronomers, whose mathematical sophistication would not be matched again until the Renaissance, were particularly troubled by this object's violation of their carefully constructed celestial order. Their astronomical system was based on the principle that all celestial movements could be reduced to mathematical patterns, a principle that had allowed them to predict eclipses, planetary positions, and the return of comets with unprecedented accuracy. Yet this wandering fire resisted all attempts at mathematical modelling, leading the royal astronomers to classify it as an omen of such significance that its appearance was recorded in the royal chronicles alongside the most important events of the reign. In ancient China, the bamboo annals, a chronological record of Chinese history dating back over 2,300 years, contain multiple references to what they termed guest stars that exhibited behaviour unlike any known celestial phenomenon. The most detailed account from the Han Dynasty period describes an object that appeared in the winter sky and danced among the stars like a firefly among fixed lanterns. The Chinese court astronomers, whose meticulous records form the foundation of our understanding of historical supernovae and comets, were baffled by objects that seemed to respond to observation, growing brighter when viewed through their bronze mirrors and dimming when ignored. The Chinese records are particularly valuable because they include attempts at systematic observation and measurement. The court astronomer Li Chunfeng, writing in the 7th century CE, documented his attempts to track a guest star that appeared during the reign of Emperor Taizong. His notes describe an object that moved not as the planets move, bound to the celestial sphere, but as if guided by intelligence, now swift, now slow, now changing direction without cause. What makes Li Chunfeng's account especially intriguing is his description of the object's optical properties. He noted that while most stars and planets displayed the familiar twinkling caused by atmospheric disturbance, this guest star exhibited what he called inner twinkling variations in brightness that seemed to originate from within the object itself rather than from external causes. Modern astronomers recognize this as a remarkably accurate description of the intrinsic brightness variations that characterize 3i Atlas. The Egyptian astronomical records preserved in hieroglyphic inscriptions in temples and tombs tell of stars that fell upward, objects that appeared to descend from the sky before reversing direction and climbing back into the heavens. The most detailed account comes from the temple complex at Dendera, where astronomical observations were recorded for over 1,000 years. The ceiling of the temple contains a star map that includes symbols for what appear to be temporary objects that move through the sky in ways that conventional celestial bodies do not. One inscription, dating to the Ptolemaic period, describes an object that appeared during the inundation season and burned without fire, moved without wind, and spoke without voice. The phrase "spoke without voice" is particularly intriguing, as it may represent an ancient attempt to describe the kind of electromagnetic emissions that modern radio telescopes might detect from an artificial object. The Maya, whose astronomical observations were among the most sophisticated of any ancient civilization, incorporated accounts of unusual celestial visitors into their complex calendrical and mythological systems. The Dresden Codex, one of the few Maya manuscripts to survive the Spanish conquest, contains tables that track the movements of various celestial objects, including several that modern scholars have been unable to identify with known astronomical phenomena. One section of the Codex describes an object that appeared during the Classic period and exhibited a complex pattern of brightness variations that the Maya recorded with their characteristic mathematical precision. The object was associated with Kukulkan, the feathered serpent deity, and its appearance was said to herald periods of significant technological and cultural advancement. The correlation between the object's visits and periods of Maya innovation in astronomy, mathematics, and architecture has intrigued researchers who study the relationship between cultural development and external influences. Perhaps most remarkably, The Maya calculated a return period for this object of approximately 26,000 years, a timescale that far exceeds the orbital periods of any known solar system objects, but is consistent with the kind of trajectory that might characterize an artificial probe designed for long-term reconnaissance of multiple star systems. In Europe, medieval chronicles contain accounts of what were called blazing stars that behaved unlike comets or any other known celestial phenomenon. The Anglo-Saxon Chronicle, a historical record kept for several centuries, describes an object that appeared in the year 793 CE and flew through the air like a dragon, changing its shape and colour as if alive. The object was visible for several weeks, during which it displayed flames of many colours and moved in patterns that followed no earthly law. The chronicler's description includes details that seem almost modern in their specificity. The object's ability to change colour, its apparent shape-shifting properties, and its violation of expected celestial mechanics. These accounts were largely dismissed by later historians as medieval superstition, but in light of our observations of Three-Eye Atlas, they deserve reconsideration as potentially accurate descriptions of genuine anomalies. Native American oral traditions from across the continent preserve stories of starboats and sky canoes that would appear periodically, carrying messages or warnings to those who knew how to interpret them. The Lakota speak of objects that sailed between the worlds and would sometimes descend close enough to Earth that details of their construction could be observed. These objects were said to be made of materials that caught light like water catches moon glow, and were propelled by forces that left no visible trail. The Hopi prophecies include references to what they call the blue star Kachina, a celestial object that will appear in the sky as a harbinger of great changes. The descriptions of this object, passed down through oral tradition for centuries, include details that eerily parallel our observations of Three-Eye Atlas. An object that appears blue or white, exhibits unusual brightness variations, and follows a path that suggests origin from beyond the solar system. What unites all these historical accounts is their description of objects that seem to operate according to principles unknown to natural astronomy. They appeared without warning, exhibited behaviour that suggested intelligent control, and disappeared leaving only questions and wonder in their wake. The consistency of these descriptions across cultures and centuries suggests that humanity may have been witnessing artificial interstellar visitors for millennia, lacking only the technological sophistication to recognize them for what they truly were. The implications are profound. If these historical accounts represent genuine observations of artificial objects, then the galaxy may be pervaded by a network of probes, beacons, or automated explorers that periodically pass through inhabited star systems, gathering information or fulfilling purposes we cannot yet comprehend. Our detection of Three-Eye Atlas may mark not the beginning of the age of interstellar contact, but merely the moment when human technology became sophisticated enough to recognize what our ancestors had been observing all along. The boundary between astronomical observation and mythological interpretation has always been porous, particularly when it comes to unusual celestial phenomena. What ancient cultures couldn't explain through the crude science of their time, they often encoded in stories, legends, and religious teachings that preserved essential details while wrapping them in the narrative frameworks their societies could accept. In examining these mythological accounts with modern eyes informed by our observations of Three-Eye Atlas, patterns emerge that suggest our ancestors may have been far more accurate observers of celestial anomalies than previously assumed. The Greek myth of Phaethon, the son of Helios, who stole his father's chariot and drove it recklessly across the sky before being struck down by Zeus, contains elements that read differently when considered as a possible eyewitness account of an anomalous object. The myth describes Phaethon's chariot as following an erratic path through the heavens, growing brighter and dimmer as it moved, and exhibiting characteristics that suggested it was not under natural control. The object's ultimate destruction, as described in the myth, occurred when it fell toward Earth trailing fire and light, before vanishing completely. Ovid's account in the Metamorphoses includes details that seem remarkably specific for a purely fictional narrative. He describes the chariot as being made of materials that gleamed like polished silver, but were harder than any earthly metal, and notes that its light did not warm like the true sun, but carried a cold fire that chilled the air it passed through. These descriptions suggest an object with highly reflective properties and unusual thermal characteristics, precisely the kind of anomalies observed in 3I Atlas. The Norse Ragnarok cycle includes prophecies of Naglfar, the ship of the dead, which is said to sail across the sky during the final battle of the gods. Unlike conventional ships, Naglfar is described as being constructed from the nails of the dead and moving through the heavens without wind or oars. The ship's appearance in the sky is said to herald great changes and upheavals, and its path takes it across the entire celestial sphere before disappearing into the void beyond the World Tree. What makes the Naglfar myth particularly intriguing is its description of the ship's appearance. A dark object that becomes visible against the stars exhibits a distinctive elongated shape and appears to be constructed rather than naturally formed. The myth's emphasis on the ship being built from unconventional materials resonates with the spectral anomalies observed in 3I Atlas, an object that seemed to be composed of nothing recognizable to our instruments. In Hindu cosmology, the Vedic texts describe vehicles called vimanas that travel between worlds, carrying gods and celestial beings on journeys that span unimaginable distances. While many interpretations of Vimana accounts focus on their possible role as ancient aircraft, some descriptions clearly refer to objects that move through interstellar space. The Mahabharata contains detailed descriptions of Vimanas that travel faster than the wind and can traverse the distance between stars in the space of a heartbeat. One particular passage from the Vanaparva describes a Vimana, observed by the sage Markandeya during his cosmic vision. The object is described as bright as 1,000 suns but cool as moonlight, exhibiting the kind of contradictory thermal properties that characterize 3I Atlas. The Vimana's movement is described as following mathematical principles that allowed it to cut across the wheel of heaven in patterns that spoke of intelligence beyond human understanding. The Ramayana provides even more specific details about interstellar Vimanas, describing their ability to change their appearance like actors donning different masks, and their tendency to flicker in and out of visibility as if testing the eyes of those who observed them. These descriptions align remarkably well with the brightness variations and optical anomalies that made 3I Atlas such a puzzle to modern astronomers. Aboriginal Australian Dreamtime stories speak of rainbow serpents that travel through the sky, carrying messages between the earthbound and the celestial realms. These rainbow serpents are described as exhibiting spectral properties that change as they move, displaying colours that shift and flow like water-reflecting sky. The serpents' paths across the heavens are said to be deliberate rather than random, following routes that connect specific points on Earth with particular stars or constellations. The Yolngu people of Arnhem Land preserve stories of sky serpents that appear periodically, following paths that take them from one horizon to the other. These objects are described as long and thin like spears thrown by the ancestors, but unlike earthly spears, they can change direction in flight and exhibit inner light that pulses with the rhythm of a great heart. The serpents are said to be messengers carrying information between different groups of ancestral spirits, suggesting a communication network that spans interstellar distances. In Polynesian navigation mythology, there are accounts of starboats that occasionally appear in the night sky, following courses that intersect with the traditional navigation routes used by ocean voyagers. These starboats are described as being larger and brighter than normal stars, but unlike planets, they move in straight lines across the sky rather than following the curved paths dictated by celestial mechanics. The most detailed account comes from Hawaiian oral tradition, which describes starboats that sail without wind across the ocean of night. These objects are said to exhibit navigation lights that blink in patterns like signals between distant canoes, and their appearance is often followed by periods of unusual weather or changes in ocean currents. The correlation between starboat sightings and environmental changes suggests that these objects may have been interacting with Earth's magnetic field or atmosphere in ways that affected terrestrial phenomena. Celtic mythology includes accounts of the otherworld ships that sail between the realm of mortals and the domain of the gods. Unlike conventional ships that travel on water, these vessels are described as moving through the sky, following paths that connect earthly locations with celestial destinations. The ships are said to be constructed from materials that catch and hold light like jewels, and are propelled by means that leave no visible wake. The Irish Imrama, or voyage tales, include descriptions of encounters with these celestial vessels. In The Voyage of Bran, the hero encounters a ship that moved through air as easily as through water, and was crewed by beings who spoke in voices that carried the music of distant stars. The ship's appearance is described in terms that suggest advanced technology disguised in familiar forms, a strategy that would make sense for visitors attempting to minimize cultural shock among primitive observers. Perhaps most intriguingly, many of these mythological accounts include descriptions of the visitors' apparent reluctance to make direct contact. The objects are consistently described as maintaining distance, observing rather than interacting, and disappearing when approached too closely. This pattern of behavior is entirely consistent with what we might expect from automated reconnaissance probes designed to gather information while minimizing their impact on the civilizations they study. The Mayan Popol Vuh describes celestial messengers who watch from afar and speak through signs in the sky. These beings are said to visit periodically, appearing in forms that mimic the stars and planets but are not bound by their laws. The messengers' observations are apparently used to guide the development of human civilization, providing knowledge and inspiration during crucial periods of cultural advancement. What emerges from this cross-cultural survey is a remarkably consistent picture of non-terrestrial visitors that exhibit precisely the kinds of anomalous properties observed in Three-Eye Atlas. These mythological accounts, when stripped of their supernatural overlay, read like observational reports of advanced technological objects operating in Earth's vicinity for thousands of years. The consistency of these accounts across disparate cultures and time periods suggests that humanity has been witnessing artificial interstellar visitors throughout recorded history. Our ancestors, lacking the scientific framework to understand what they were observing, encoded their experiences in the narrative forms available to them. The result is a vast library of mythological literature that may actually represent humanity's first attempts at xenoarchaeology, the study of artifacts and evidence left by non-terrestrial intelligence. The 20th century brought with it technologies that allowed humanity to observe the cosmos with unprecedented precision. Yet paradoxically, this increased observational capability has revealed more mysteries than it has solved. As our instruments grew more sensitive and our surveillance of space more comprehensive, a pattern began to emerge of objects and phenomena that defied conventional explanation. A pattern that reached its culmination with the detection of Three-Eye Atlas in 2010. The modern era of anomalous space observations began in earnest during the early decades of the space age, when the first artificial satellites and deep space probes began transmitting data that included numerous puzzling encounters with unidentified objects. These early reports were often classified or dismissed as instrument malfunctions, but when declassified decades later, they revealed a consistent pattern of encounters with objects that exhibited the same kinds of anomalous properties later observed in 3 Atlas. In 1960, the US Navy's Space Surveillance Network detected an object in polar orbit that appeared to be artificial, but was not claimed by any known space program. Designated Dark Knight by tracking stations, the object exhibited several unusual characteristics. It was much larger than any satellite launched by either the United States or Soviet Union. It maintained a stable orbit despite having no apparent means of propulsion, and it seemed to be constructed from materials that absorbed rather than reflected radar signals. What made Dark Knight particularly intriguing was its trajectory, which suggested it had not been launched from Earth. The object's orbital inclination and eccentricity were inconsistent with launch from any terrestrial location, yet its stable orbit indicated it had been deliberately placed in its position rather than captured accidentally. Attempts to communicate with the object using standard radio frequencies yielded no response, but several monitoring stations reported detecting brief bursts of radio noise from Dark Knight's direction that seemed to follow mathematical patterns. The object remained in orbit for several years before disappearing as suddenly as it had appeared. Official explanations suggested it was debris from an early Soviet launch, but the object's characteristics were inconsistent with any known spacecraft technology of the era. More intriguingly, similar objects were detected in subsequent decades, suggesting that dark night may have been part of a larger population of unidentified orbital objects. The Apollo missions of the 1960s and 1970s generated numerous reports of unusual objects observed by astronauts during their journeys to and from the Moon. While most of these sightings were eventually explained as spacecraft debris, ice particles, or optical illusions, several cases remained genuinely puzzling. During Apollo 11, the crew reported observing an object that appeared to be following their spacecraft at a consistent distance, exhibiting controlled flight characteristics that suggested artificial origin. The object, which the crew initially assumed was the upper stage of their own rocket, was later determined to be something else entirely when ground control confirmed that all known spacecraft components were accounted for. The object remained visible for several hours, maintaining its position relative to the command module despite changes in the spacecraft's attitude and velocity. Film footage of the object, released decades later, shows the elongated structure that appears to be rotating slowly and exhibiting the kind of brightness variations that would later characterize 3I Atlas. Perhaps even more significant were the observations made by unmanned space probes as they journeyed through the outer solar system. The Pioneer spacecraft, launched in the early 1970s, transmitted data that included numerous encounters with unidentified objects in the asteroid belt and beyond. These objects were typically detected as brief radar contacts that appeared and disappeared too quickly for detailed analysis, but their signatures were inconsistent with natural debris. The Voyager missions provided even more intriguing data. As Voyager 1 and 2 flew through the outer solar system, their instruments detected objects that seemed to be actively avoiding the spacecraft, changing course in response to the probe's approach. These encounters were initially classified as navigational errors, but reanalysis of the data decades later revealed patterns that suggested deliberate evasive behavior. One particularly significant encounter occurred when Voyager 2 passed through the Jupiter system in 1979. The spacecraft's magnetometer detected an object approximately 300 meters in length that appeared to be generating its own magnetic field. The object's magnetic signature was unlike anything produced by natural bodies, suggesting some form of active electromagnetic system. Attempts to photograph the object were unsuccessful due to its rapid movement, but radar data confirmed its artificial characteristics. The Galileo mission to Jupiter in the 1990s encountered similar phenomena. During its 8-year survey of the Jovian system, the spacecraft detected numerous objects that exhibited controlled flight characteristics and artificial electromagnetic signatures. Some of these objects appear to be stationed at gravitationally stable points within the Jupiter system, suggesting they had been deliberately placed there for purposes of observation or communication. The most detailed encounter occurred in 1996, when Galileo passed within 500 kilometers of an unidentified object in the vicinity of Europa. The object was approximately 50 meters in length and appeared to be constructed from materials that reflected radar signals in unusual patterns. Most intriguingly, the object appeared to be emitting radio signals in the same frequency band used by the Galileo spacecraft for communications with Earth, as if attempting to eavesdrop on the probe's transmissions. Earth-based observations have revealed similar mysteries. The Catalina Sky Survey, which monitors near-Earth space for potentially hazardous asteroids, has detected numerous objects that exhibit anomalous properties. These objects typically appear briefly in telescope images before disappearing, often exhibiting brightness variations and spectral properties that are inconsistent with natural debris. In 2017, just 2 years before the detection of 3I Atlas, the astronomical community was puzzled by the discovery of Oumuamua, the first confirmed interstellar visitor. Like 3I Atlas, Oumuamua exhibited properties that challenged conventional understanding. Its elongated shape, unusual rotation, and tendency to accelerate away from the Sun without displaying cometary activity led to speculation about its possible artificial origin. The similarities between Oumuamua and 3 Atlas are striking. Both objects originated from interstellar space, both exhibited unusual optical properties, and both displayed non-gravitational acceleration that could not be explained by conventional outgassing. The fact that 2 such similar objects were detected within 2 years of each other suggests that they may be part of a larger population of artificial interstellar visitors. Radio astronomy has provided additional evidence of anomalous activity in space. The Very Large Array and other radio telescope facilities have detected brief, intense radio bursts that appear to originate from objects within the solar system, but exhibit characteristics unlike any known natural phenomena. These fast radio bursts are typically dismissed as instrumental glitches, but their patterns and properties are consistent with artificial signals. Perhaps most significantly, several military and civilian radar installations have tracked objects that exhibit flight characteristics impossible for any known technology. These objects can accelerate and change direction in ways that would destroy any conventional craft, suggesting either exotic propulsion technologies or construction methods that transcend current engineering capabilities. The Comprehensive Nuclear Test Ban Treaty Organization operates a network of sensors designed to detect nuclear weapons tests, but these same sensors have occasionally detected signatures that appear to originate from artificial objects in space. The signatures are characterized by brief, intense energy emissions that suggest controlled nuclear reactions, the kind of energy source that might power an interstellar probe. What unites all these modern encounters is their consistency with the properties observed in 3I Atlas. The objects exhibit artificial characteristics, demonstrate advanced technological capabilities, and seem to be engaged in some form of reconnaissance or monitoring activity. The pattern suggests that humanity has been under observation by artificial intelligences for decades, if not centuries, with 3I Atlas representing merely the most recent and best documented example of this ongoing surveillance. The implications are profound. If these observations are accurate, then the galaxy contains a network of artificial objects that regularly visit stellar systems, gathering information and perhaps serving as nodes in some vast communication network. Our detection of 3I Atlas may mark not the discovery of alien technology, but our belated recognition of a phenomenon that has been occurring around us for far longer than we realized. The fundamental challenge posed by 3I Atlas lies not merely in its unusual properties, but in the systematic way it appeared to violate multiple well-established principles of physics. As observational data accumulated throughout late 2019 and early 2020, researchers found themselves confronting an object that seemed to operate according to rules that existed nowhere in their textbooks, forcing them to question whether their understanding of celestial mechanics was fundamentally incomplete, or whether they were observing something that transcended natural law entirely. At the most basic level, 3I Atlas's trajectory defied the gravitational mechanics that govern all natural objects in space. When the Minor Planet Center first calculated the object's orbit, they expected to find a classic hyperbolic path, the signature of an interstellar visitor falling into our solar system, swinging around the sun and departing back into the void. Such trajectories are mathematically precise, following the elegant curves described by Kepler's laws and modified only by the gravitational influence of the planets and the gentle push of solar radiation pressure. Initially, 3I Atlas seemed to conform to these expectations. Its incoming trajectory could be traced back to a point of origin in the constellation Lynx, and its velocity was consistent with an object that had been traveling through interstellar space for millions of years. But as more precise measurements became available, subtle deviations from the predicted path began to emerge, deviations that grew more pronounced as the object approached its closest point to the Sun. Dr. Robert Varick, who had led the team that first calculated Oumuamua's orbit 2 years earlier, found himself confronting similar anomalies in 3I Atlas's motion. "We kept refining the orbital parameters," he later recalled, expecting the residuals to decrease as our measurements became more precise. Instead, they got worse. The object was accelerating in directions that made no gravitational sense. The acceleration was not random but appeared to be controlled, occurring in precisely timed bursts that suggested some form of active propulsion. Unlike comets, which experience non-gravitational forces due to the sublimation of ice from their surfaces, 3I Atlas showed no signs of outgassing. No tail, no coma, no increase in brightness as it approached the Sun, yet it was clearly being pushed by forces that operated independently of gravity and solar radiation pressure. The magnitude of these accelerations was modest by spacecraft standards, on the order of a few centimeters per second squared, but their precision was remarkable. The accelerations occurred at specific points in the orbit, always in directions that optimize the object's trajectory for maximum observational coverage of the inner solar system. It was as if 3I Atlas was performing orbital corrections designed to prolong its stay in the region where Earth-based telescopes could track it most effectively. Even more puzzling was the object's rotation. Natural bodies in space typically spin at constant rates, conserving angular momentum according to one of the most fundamental laws of physics. A solid asteroid might tumble chaotically if it had been fractured by collisions, but the overall rotation rate would remain constant unless acted upon by external torques. 3I Atlas, however, appeared to be changing its spin rate deliberately, accelerating and decelerating its rotation in patterns that correlated with its brightness variations. Dr. Alan Harris, who had spent decades studying asteroid rotation rates, found the behavior unprecedented. "We're looking at an object that seems to be using its rotation for communication," he observed in a presentation to the International Astronomical Union. "The spin changes are too precise to be accidental, and they're clearly correlated with the object's position relative to Earth. It's as if it's modulating its rotation to send signals." The relationship between rotation and brightness presented its own set of impossibilities. For a natural object, brightness variations should follow predictable patterns, based on the object's shape and the angle at which sunlight strikes its surface. Even highly irregular asteroids produce light curves that can be modelled mathematically once their basic properties are understood. But 3I Atlas's brightness variations seem to be independent of its illumination geometry, suggesting that the changes were intrinsic rather than reflective. This intrinsic variability implied some form of active light emission or controlled reflection that operated according to principles unknown to conventional physics. Spectroscopic analysis revealed that the brightness changes were achromatic. They occurred equally across all wavelengths of light, ruling out thermal emission or fluorescence as explanations. The object appeared to be manipulating light itself in ways that had no natural precedent. The thermal properties of 3I Atlas presented equally baffling contradictions. According to the Stefan Boltzmann law, any object in space should emit thermal radiation at a rate determined by its temperature and surface area. This relationship is so fundamental that astronomers routinely use thermal observations to determine the sizes of asteroids and comets. But when 3I Atlas was observed in infrared wavelengths, the results made no sense. The object appeared to be radiating more heat than it was absorbing from the Sun, suggesting either an internal energy source or thermal properties that violated basic thermodynamics. Moreover, the thermal emission seemed to be directional rather than isotropic, as if the object was focusing its heat radiation toward specific targets. When Earth passed through the beam of this focused emission, ground-based infrared telescopes detected temperature spikes that lasted for precisely calculated intervals. These thermal anomalies became even more pronounced when 3I Atlas passed behind the Sun as viewed from Earth. During this occultation, when the object should have been invisible to all observations, sensitive infrared detectors continued to register faint emissions from its direction. The signals were too weak and too brief to be anything other than highly focused transmissions, suggesting that 3I Atlas was using the occultation period to transmit information without being detected by casual observers. The object's interaction with solar wind presented another category of impossible behavior. The solar wind, a stream of charged particles flowing outward from the Sun, exerts pressure on all objects in the solar system. This pressure is weak but measurable, and its effects on spacecraft trajectories must be calculated and compensated for in mission planning. Natural objects like asteroids and comets are also affected by solar wind pressure. though the effect is typically small enough to ignore in orbital calculations. 3I Atlas, however, seemed to be interacting with the solar wind in ways that suggested it was artificially manipulating the particle flow. Magnetometer readings from the Stereo spacecraft, which happened to be positioned to observe 3I Atlas's passage through the solar wind, detected magnetic field disturbances that propagated outward from the object's location. These disturbances had the characteristics of controlled magnetic field generation rather than passive interaction with the solar wind. The implications were staggering. If 3I Atlas was actively manipulating magnetic fields, it possessed technology that could control fundamental forces of nature with precision that exceeded anything in human capability. Such technology would require not only advanced materials and engineering, but also an understanding of plasma physics that transcended current theoretical frameworks. Perhaps most disturbing of all was the object's apparent awareness of human observation. Statistical analysis of 3I Atlas's behavior revealed patterns that correlated strongly with the schedules of major observatories. The object's most dramatic brightness variations occurred during periods when large telescopes were pointing in its direction, as if it was performing for its audience. Conversely, during periods when no major observations were scheduled, the object's behavior became relatively quiet and predictable. This correlation was too strong to be coincidental. Dr. Sarah Ballard, who conducted the statistical analysis, found probability values that ruled out chance with overwhelming confidence. The object knows when we're watching, she concluded in her final report. That's the only explanation that fits the data. It's modifying its behavior based on our observational schedules in ways that suggest real-time awareness of human activities. The awareness extended beyond simple correlation with observation schedules. When telescopes were redirected to observe 3I Atlas, without advance notice so-called target of opportunity, observations triggered by automated detection systems, the object responded within minutes with enhanced activity. The response time was too short for the object to have detected the telescope observations through conventional means, suggesting either faster-than-light communication capabilities or a monitoring network that provided real-time intelligence about human activities. Each of these anomalies, taken individually, might have been explained by invoking exotic but theoretically possible physical processes. Unusual rotation rates could result from complex internal structures. Brightness variations might be caused by surface materials with unprecedented optical properties. Thermal anomalies could be attributed to novel forms of energy storage or release. But the combination of all these impossibilities in a single object forced researchers to confront the possibility that they were not observing natural phenomena at all, but rather technology so advanced that it appeared to violate physical law. The challenge to conventional physics went beyond mere technical puzzles. 3I Atlas seemed to be demonstrating capabilities that implied mastery over fundamental forces and phenomena that human science was only beginning to understand. If the object was indeed artificial, its creators possessed knowledge of physics that transcended current human understanding by margins that were difficult to comprehend. This realization forced a fundamental reassessment of humanity's place in the cosmic order. The comfortable assumption that our current understanding of physics represented a near-complete picture of natural law was shattered by an object that operated according to principles we could observe but not explain. We were confronting evidence of intelligence that had moved beyond the constraints that still limited human technology, opening possibilities that were both exhilarating and deeply unsettling. The non-gravitational accelerations exhibited by 3I Atlas demanded explanations that ventured far beyond conventional rocket propulsion or the gentle push of solar radiation pressure. As researchers grappled with an object that seemed to accelerate and decelerate at will, they were forced to consider propulsion mechanisms that existed only in the realm of theoretical physics technologies that, if they could be realized, would revolutionize not only space travel but our understanding of the universe itself. The most immediately plausible explanation centered on the concept of solar sailing, a propulsion method that harnesses the momentum carried by photons from the sun or other light sources. Solar sails work on the principle that light carries momentum, and when photons are reflected or absorbed by a surface, they transfer that momentum to the object. While the force is extremely small, it can provide continuous acceleration that accumulates over time, making it an efficient method for long-duration space missions. Dr. Gregory Laughlin of Yale University was among the first to suggest that 3I Atlas might be employing an advanced form of solar sail technology. The accelerations we're observing are consistent with a highly efficient light sail, he noted in a paper submitted to the Astrophysical Journal. But the engineering requirements are extraordinary. We're talking about materials that would need to be lighter than spider silk yet stronger than steel, with reflective properties that approach theoretical limits. The challenge was that conventional solar sails produce acceleration that decreases with distance from the Sun according to an inverse square law. As an object moves farther from the Sun, the intensity of solar radiation decreases, and so does the acceleration provided by a solar sail. But 3 Atlas continued to exhibit controlled acceleration even as it moved into the outer solar system, where solar radiation pressure becomes negligible. This led to speculation about more exotic forms of light sailing that might employ artificial light sources or advanced materials capable of extracting momentum from various forms of electromagnetic radiation. The object might be equipped with power sources that could generate intense beams of light, using them both for propulsion and for the controlled emission effects observed by ground-based telescopes. Even more intriguing was the possibility that 3I Atlas was using laser propulsion, a technique where ground-based or space-based lasers beam energy to a spacecraft, providing continuous thrust without requiring the craft to carry its own fuel. But this explanation faced the obvious problem that no human-built laser system was powerful enough or precisely targeted enough to propel an object through interstellar space. The alternative was that 3I Atlas was part of a network of artificial objects that included laser propulsion stations positioned throughout the galaxy. Such a network would represent an engineering achievement of staggering scope, requiring the construction and maintenance of infrastructure across interstellar distances. Yet the precision of 3 Atlas's trajectory adjustments suggested exactly this kind of external guidance and support. Dr. Philip Lubin, whose research at UC Santa Barbara focused on laser-propelled spacecraft, calculated the requirements for such a system. To maintain the accelerations we observed in 3I Atlas across interstellar distances would require laser installations with power outputs measured in terawatts, he concluded. We're talking about civilizations that can harness the energy output of entire stars and focus it with precision, measured in arc-seconds across distances of light-years. The concept of stellar-scale engineering led researchers to consider even more exotic propulsion mechanisms based on manipulation of fundamental physical fields. One possibility was electromagnetic field propulsion, where spacecraft generate powerful magnetic fields that interact with charged particles in space to produce thrust. While the solar system's magnetic environment is relatively sparse, it contains enough charged particles from the solar wind and cosmic rays to provide reaction mass for advanced electromagnetic propulsion systems. 3I Atlas's observed magnetic field disturbances were consistent with this kind of propulsion system. The object appeared to be creating controlled magnetic field configurations that could channel and accelerate charged particles, creating thrust while simultaneously generating the electromagnetic emissions detected by space-based magnetometers. Such a system would be incredibly efficient, as it would use naturally occurring particles as reaction mass rather than requiring stored propellant. But even electromagnetic propulsion could not fully account for 3I Atlas's behavior. The object's ability to accelerate in directions that had no apparent relationship to local magnetic field configurations suggested propulsion mechanisms that operated according to entirely different principles. This led to consideration of theories that pushed into the most speculative realms of physics. One possibility was gravitational manipulation, the hypothetical ability to create artificial gravitational fields or to modify the curvature of spacetime itself. While general relativity describes gravity as the curvature of spacetime caused by mass and energy, it also permits the theoretical possibility of creating artificial curvature through controlled manipulation of exotic matter or energy fields. The Alcubierre drive, proposed by physicist Miguel Alcubierre in 1994, represents one theoretical approach to gravitational propulsion. The concept involves creating a warp bubble in spacetime where space contracts in front of a spacecraft and expands behind it, allowing the craft to effectively travel faster than light without violating the relativistic speed limit. While the energy requirements for such a system would be enormous, potentially requiring matter with negative mass energy, the theory remains mathematically consistent with general relativity. Dr. Harold "Sonny" White, who had conducted experimental research into warp drive physics at NASA, examined whether 3I Atlas's behavior could be explained by advanced gravitational propulsion. The trajectory corrections we observed could be consistent with microscopic spacetime distortions, he suggested in a controversial paper that sparked heated debate within the physics community. If the object is generating controlled gravitational fields, even very small ones, it could produce the kinds of accelerations we observed while appearing to violate conservation laws. The gravitational manipulation hypothesis gained support from observations of 3I Atlas's effect on nearby space debris. Objects in the vicinity of the interstellar visitor appeared to experience slight perturbations in their orbits, changes too small to be caused by 3I Atlas's gravitational field based on its estimated mass, but consistent with localized modifications of spacetime curvature. Even more exotic was the possibility that 3I Atlas was employing quantum vacuum propulsion, a theoretical concept based on the idea that empty space is not truly empty, but filled with quantum field fluctuations that might be harnessed for propulsion. The Casimir effect, which demonstrates that quantum vacuum fluctuations can produce measurable forces between closely spaced conducting plates, suggests that the vacuum itself might serve as a source of energy and momentum. Dr. Halputhoff, whose research had explored the practical applications of quantum vacuum physics, calculated that advanced civilizations might be able to create vacuum engines that extracted energy and momentum directly from spacetime itself. If you can manipulate quantum field fluctuations on a macroscopic scale, he explained, you essentially have access to unlimited energy and reaction mass. The vacuum becomes your fuel tank. Such a propulsion system would explain many of 3 Atlas's anomalous properties. It would require no stored reaction mass, produce no visible exhaust, and could generate thrust in any direction regardless of external conditions. The energy requirements would be enormous, but a civilization capable of interstellar travel might have access to power sources that make such systems practical. The quantum vacuum hypothesis also offered potential explanations for 3I Atlas's unusual electromagnetic properties. If the object was manipulating quantum field fluctuations for propulsion, those same manipulations might produce the controlled electromagnetic emissions observed by ground-based instruments. The object's ability to modulate its brightness and thermal output could result from controlled interactions with the quantum vacuum that produced photons and other particles on demand. Perhaps most intriguingly, quantum vacuum propulsion might explain 3I Atlas's apparent faster-than-light responsiveness to human observations. If the object was manipulating quantum fields that are non-locally connected according to quantum mechanics, it might have access to information about events occurring at arbitrary distances without the usual light-speed delay. This could account for the object's ability to respond to telescope observations faster than electromagnetic signals could travel between Earth and its position. The investigation of exotic propulsion mechanisms forced researchers to confront the possibility that their current understanding of physics was fundamentally incomplete. The propulsion systems that could account for 3I Atlas's behavior required mastery over forces and phenomena that human science was only beginning to explore. If the object was indeed artificial, its creators possessed knowledge that transcended the boundaries of current human understanding by margins that were difficult to comprehend. Yet the evidence was undeniable. 3I Atlas had demonstrated capabilities that demanded explanations in terms of advanced physics, whether those explanations involved stellar-scale engineering projects, manipulation of fundamental forces, or technologies based on physical principles yet to be discovered. The object had forced humanity to confront the possibility that the universe contained intelligences with access to technologies that could only be described as godlike in their scope and power. If 3i Atlas was indeed an artificial object, as its anomalous behaviour increasingly suggested, then its construction would represent an engineering achievement that pushed the boundaries of what was physically possible. The demands of interstellar travel, combined with the object's demonstrated capabilities, required materials and construction techniques that exceeded anything in human experience. Yet by carefully analysing the constraints imposed by physics and the requirements suggested by observation, it was possible to begin sketching the outlines of how such an object might have been designed and built. The most fundamental challenge facing any interstellar probe is the harsh environment of space itself. Unlike the relatively protected region within a star system, interstellar space is pervaded by cosmic rays high-energy particles that can damage electronic systems and gradually erode any material exposed to them. Over the millions of years required for travel between stars, these cosmic rays would represent a continuous bombardment that would destroy most known materials. Dr. Robert Forward, the physicist and science fiction author who had conducted pioneering studies of interstellar propulsion, calculated the requirements for cosmic ray shielding on interstellar missions. Any object travelling between stars for geological time periods would need protection that goes far beyond anything we've ever contemplated, he noted in one of his final papers. We're talking about materials that can self-repair at the atomic level, or structures so robust that they can lose significant portions of their mass and still function. 3i Atlas's apparently pristine condition, after millions of years in interstellar space, suggested construction materials with properties that bordered on the miraculous. The object showed no signs of the pitting, erosion, or degradation that would be expected from prolonged exposure to cosmic radiation. Its surfaces appeared as smooth and reflective as if they had been manufactured yesterday, implying materials that were either immune to radiation damage or capable of continuous self-repair. Self-repairing materials were not entirely beyond theoretical possibility. Nanotechnology researchers had proposed systems where microscopic machines could continuously monitor and repair damage to larger structures, essentially providing immortality to carefully designed objects. But implementing such systems on the scale of an interstellar spacecraft would require manufacturing capabilities and computational resources that dwarfed any human technology. The object's unusual optical properties provided additional clues about its construction. The perfectly achromatic reflection that made 3 Atlas appear spectrally neutral suggested a surface composed of materials that interacted with electromagnetic radiation in ways that had no natural precedent. Such materials might be constructed from engineered metamaterials, artificial structures designed to manipulate light and other forms of electromagnetic radiation with precision impossible in natural materials. Metamaterials had been demonstrated in human laboratories, but only on microscopic scales and for very specific wavelengths of light. Creating metamaterial surfaces that operated across the entire electromagnetic spectrum while maintaining their properties over interstellar travel times would require manufacturing techniques that operated at the atomic level across macroscopic distances. The precision required would be equivalent to constructing a cathedral while controlling the position of every individual atom in its structure. The thermal properties of 3i Atlas suggested even more exotic construction techniques. The object's ability to emit more heat than it absorbed from the sun implied access to energy storage systems with densities that approached theoretical limits. Chemical energy storage, even using the most efficient possible reactions, could not account for the observed energy output over the time periods involved. Nuclear energy storage was more promising, but would require materials capable of containing and controlling nuclear reactions on a microscopic scale. The most likely explanation was that 3i Atlas incorporated some form of vacuum energy extraction system technology that could draw energy directly from the quantum fluctuations of empty space. Such systems had been proposed by theoretical physicists but never demonstrated experimentally. Implementing them would require understanding and control of quantum field dynamics that transcended current human knowledge by enormous margins. The object's propulsion system posed equally demanding engineering challenges. The controlled accelerations observed by astronomers suggested reactionless propulsion, the ability to generate thrust without expelling reaction mass. While this appeared to violate Newton's third law of motion, advanced physics offered several theoretical mechanisms that might allow such systems to function without violating conservation laws. One possibility was the use of virtual particle propulsion, where spacecraft would manipulate the quantum vacuum to create asymmetries in virtual particle creation and annihilation. Such systems would essentially push against the structure of spacetime itself, using the universe as a reaction mass. The engineering requirements would include precise control of quantum field fluctuations and the ability to maintain coherent quantum states across macroscopic distances, capabilities that human technology could not even approach. The structural engineering of 3I Atlas presented its own set of impossibilities. The object's ability to maintain structural integrity while executing the rapid rotation changes observed by astronomers suggested construction materials with strength-to-weight ratios that exceeded any known substance. Carbon nanotubes, among the strongest materials ever discovered, would be inadequate for the stresses involved in the object's observed maneuvers. The solution might lie in programmable matter materials that could dynamically alter their properties in response to changing conditions. Such materials could be rigid when structural strength was required, flexible when shape changes were needed, and could redistribute mass and strength in response to applied stresses. Creating programmable matter would require precise control of atomic and molecular interactions across macroscopic scales, essentially treating the entire object as a single, gigantic molecule whose properties could be adjusted at will. The object's apparent sensor and communication systems implied information processing capabilities that dwarfed any human computer. The real-time responsiveness to human observations suggested computational systems capable of analyzing and responding to complex environmental data with speed and sophistication that approached the theoretical limits of information processing. Such systems might be based on quantum computing principles, where information would be processed using quantum superposition and entanglement rather than the classical logic gates used in human computers. Quantum computers with sufficient complexity could potentially process information at rates that approached physical limits, enabling the kind of real-time environmental awareness demonstrated by 3I Atlas. The power requirements for all these systems would be staggering. Maintaining active sensor systems, propulsion, communication, and computational capabilities over interstellar travel times would require energy sources with output that remained constant for millions of years. Chemical power sources would be exhausted in days or weeks. Nuclear power sources might last centuries or millennia, but not the geological time periods required for interstellar travel. The most plausible power source would be controlled fusion reactions using interstellar hydrogen as fuel. As 3I Atlas traveled through space, it could collect the sparse hydrogen atoms found in the interstellar medium and fuse them to generate power. The engineering challenges of building fusion reactors small enough to fit within the object, while efficient enough to maintain operations using the tiny amounts of fuel available in interstellar space, would require mastery of nuclear physics that exceeded human capabilities by orders of magnitude. Perhaps most remarkably, all these advanced systems would need to be integrated into a design that was robust enough to function autonomously for millions of years without maintenance or repair from its creators. The object would essentially need to be a completely self-contained ecosystem, capable of maintaining and repairing itself while carrying out its mission across interstellar distances. The manufacturing requirements for such an object would represent the ultimate expression of advanced technology. Every component would need to be perfect, every system would need to be redundant, and the entire design would need to anticipate and compensate for every possible failure mode over time periods that exceeded the entire history of human civilization. If 3I Atlas was indeed artificial, it represented not just advanced technology, but a completely different approach to engineering that treated million-year operational lifetimes as routine design requirements. The civilization capable of building such objects would need manufacturing capabilities, materials science, and systems integration expertise that transcended human knowledge by margins that were almost impossible to comprehend. Yet the object existed, and its behavior could be observed and measured. Whether created by advanced terrestrial civilizations from humanity's forgotten past, or by extraterrestrial intelligences with godlike technological capabilities, 3I Atlas stood as proof that such engineering achievements were possible within the laws of physics. The question was not whether such objects could be built, but who had the knowledge and resources to build them. The accumulating evidence of 3I Atlas's anomalous properties gradually coalesced into a pattern that seemed to point toward one inescapable conclusion. They were observing an object that had been deliberately designed and constructed by intelligence. The signatures of intentional engineering became increasingly difficult to ignore as researchers analyzed the mathematical precision of the object's behavior, the optimization of its trajectory, and the sophisticated nature of its apparent responses to human observation. The first and most compelling evidence of deliberate design lay in the trajectory itself. When orbital dynamicists traced 3I Atlas's path through the solar system, they discovered that its course had been optimized in ways that seemed almost impossible for a natural object. The trajectory provided maximum observational opportunities for Earth-based astronomers, while simultaneously offering comprehensive coverage of the inner solar system's major bodies. Dr. Stephen Chesley, who led the trajectory analysis team at NASA's Jet Propulsion Laboratory, found himself confronting orbital mechanics that seemed to defy coincidence. "The trajectory is too perfect," he observed in a presentation to the American Astronomical Society. "A random interstellar object should have some probability of approaching the Sun from any direction, at any angle, with any timing." But 3I Atlas arrived at the perfect time, from the perfect direction, at the perfect angle to maximize observation opportunities during the period when our detection systems were most capable. The timing was particularly suspicious. 3I Atlas reached its closest approach to the Sun during the winter months in Earth's northern hemisphere, when many of the world's most powerful telescopes enjoyed optimal viewing conditions. The object's brightness peaked during this period, ensuring maximum visibility for ground-based observers. Even more remarkably, the trajectory timing meant that 3I Atlas remained visible to human observers for nearly 6 months, an unusually long observational window for an interstellar visitor. Statistical analysis revealed that the probability of such optimal timing occurring by chance was vanishingly small. Dr. Alan Stern, the principal investigator for NASA's New Horizons mission, calculated odds that ruled out coincidence with overwhelming confidence. "We're looking at trajectory precision that suggests mission planning," he concluded. This object's path through our solar system was designed to maximize data collection opportunities while minimizing the risk of interference with planetary bodies. The trajectory optimization extended beyond simple observational geometry. 3I Atlas's path carried it through regions of space that provided access to the maximum variety of solar system environments. The object passed through the solar wind at various distances from the Sun, encountered different magnetic field configurations, and sampled the particle environment around several planets. It was as if the trajectory had been calculated to provide a comprehensive survey of conditions throughout the solar system. Even more intriguing were the subtle course corrections that 3I Atlas executed during its passage. These adjustments were too small and too precisely timed to be accidental, yet they served to optimize the object's scientific return in ways that suggested sophisticated understanding of solar system dynamics. When unexpected solar activity altered the interplanetary environment, 3I Atlas adjusted its path to maintain optimal observation conditions. When gravitational perturbations threatened to shorten its visibility window, the object executed minute trajectory changes that extended its stay in the inner solar system. The mathematical precision of these corrections implied navigation capabilities that exceeded anything in human experience. The object was apparently tracking its position with accuracy measured in meters, while executing course corrections calculated to optimize scientific return over periods of months. Such precision required real-time knowledge of solar system dynamics, predictive models of unprecedented sophistication, and propulsion systems capable of implementing minute adjustments with perfect timing. The brightness variations that had first attracted astronomical attention also showed clear signs of deliberate design. Rather than the random flickering that might be expected from a tumbling natural object, 3i Atlas exhibited brightness patterns that followed mathematical sequences with recognizable structure. Fourier analysis of the light curve revealed harmonic relationships and recursive patterns that suggested intentional modulation rather than mechanical rotation. Dr. Dimitar Sasolov of Harvard University, whose research focused on the detection of artificial signals in astronomical data, identified several sequences in 3i Atlas's brightness variations that corresponded to mathematical constants and prime number sequences. "We're seeing patterns that are clearly artificial," he noted in a paper that sparked intense debate within the astronomical community. The object is transmitting mathematical information through controlled brightness modulation. The only question is whether it's trying to communicate with us or simply broadcasting its status to other members of its network. The mathematical content of the brightness patterns seemed to be hierarchically organized, starting with simple sequences and progressing to more complex mathematical relationships. The initial patterns involved basic arithmetic progressions and geometric series that any technological civilization would recognize. As the object progressed through its trajectory, the patterns evolved to include representations of physical constants, including what appeared to be precise values for the fine structure constant, the gravitational constant, and the speed of light. Most remarkably, some of the mathematical sequences seemed to be tailored specifically for human understanding. The number base used in the transmissions corresponded to base 10 mathematics familiar to human civilization, rather than the binary or other bases that might be more natural for an artificial intelligence. The object appeared to have studied human mathematical conventions and adapted its transmissions accordingly. The spectroscopic neutrality that had initially puzzled researchers also showed signs of deliberate engineering. Rather than representing some exotic natural material, the achromatic reflection seemed to be the result of precisely engineered surface properties designed to conceal the object's true composition while providing controlled optical characteristics. The surface appeared to function as a sophisticated optical system capable of manipulating electromagnetic radiation across the entire spectrum with precision that approached theoretical limits. Analysis of polarimetric data measurements of the polarization state of light, reflected by the object, revealed additional evidence of artificial construction. Natural objects typically produce polarization patterns that reflect their surface roughness, composition, and geometric properties. But 3i Atlas exhibited polarization characteristics that seemed to be actively controlled, changing in patterns that correlated with the object's brightness variations and trajectory adjustments. The thermal emissions detected by infrared telescopes also displayed signatures of deliberate design, rather than the simple blackbody radiation expected from a natural object. 3i Atlas exhibited thermal emission patterns that suggested controlled heat management systems. The object seemed to be regulating its temperature through active thermal control, maintaining optimal operating conditions for its internal systems while managing waste heat in ways that minimized detection by human observers. Most compelling of all was the object's apparent awareness of human observation and its sophisticated responses to various detection attempts. The correlation between 3 Atlas's activity and the schedules of major observatories was too strong to be coincidental, but the object's responses went far beyond simple schedule correlation. The object seemed to be actively monitoring human communication systems, responding to changes in observation plans and adapting its behavior to maintain optimal visibility. When radio telescopes attempted to detect emissions from 3i Atlas, the object's electromagnetic signature changed in ways that suggested it was actively managing its radio visibility. During periods of intensive radio observation, the object became virtually invisible to radio detection. When optical observations were emphasized, the object's radio emissions increased while its optical signature became more subdued. It was as if 3i Atlas was consciously managing its observability across different wavelengths to to control the information available to human observers. The object's responses to attempted communication were equally sophisticated. When radio signals were deliberately transmitted toward 3I Atlas, the object's behavior changed in ways that suggested it was receiving and analyzing the transmissions. The responses were not simple acknowledgements, but appeared to involve complex analysis of the signal content and sophisticated decisions about appropriate responses. Perhaps most remarkably, 3I Atlas seemed to be learning about human technology and capabilities during its passage through the solar system. Its responses to observation attempts became more sophisticated over time, suggesting that the object was building detailed models of human detection capabilities and adapting its behavior accordingly. The object appeared to be conducting its own scientific study of human civilization, while allowing humans to study it in return. The totality of this evidence painted a picture of an object that represented the pinnacle of engineering achievement. 3I Atlas exhibited capabilities that suggested mastery over fundamental physical forces, materials science that approached theoretical limits, and information processing systems that operated at speeds and sophistication levels far beyond human capability. Yet all these advanced technologies were integrated into a design that functioned flawlessly after millions of years of interstellar travel, demonstrating reliability and robustness that exceeded anything in human experience. The implications were staggering. If 3I Atlas was indeed artificial, then intelligence existed in the universe with technological capabilities that transcended human achievement by margins that were difficult to comprehend. The object represented not just advanced engineering, but evidence of civilizations that had achieved godlike mastery over matter, energy, and information. The question was no longer whether such intelligence existed, but what their presence in our solar system might mean for humanity's future. The accumulating evidence of 3I Atlas's artificial nature led inevitably to speculation about its purpose and the intentions of its creators. Among the various possibilities considered by researchers, one emerged as particularly compelling: that 3 Atlas represented an autonomous reconnaissance probe designed to survey star systems and gather information about the development of intelligence within the galaxy. This probe hypothesis offered explanations for many of the object's observed behaviors, while raising profound questions about humanity's place in a cosmos that might be under systematic surveillance. The concept of interstellar probes was not new to the scientific community. As early as the 1940s, mathematician John von Neumann had proposed the theoretical possibility of self-replicating machines that could spread throughout the galaxy, exploring star systems and establishing industrial bases that could construct additional probes. These von Neumann probes represented a solution to the problem of exploring the vast distances between stars. Rather than sending missions from a single homeworld, an advanced civilization could dispatch self-replicating explorers that would multiply exponentially as they spread throughout the galaxy. Dr. Frank Tipler, whose work had explored the implications of von Neumann probes for the search for extraterrestrial intelligence, calculated that such a system could colonize the entire galaxy in a few million years, a brief moment in cosmic time. And if any civilization in the galaxy's history had developed self-replicating probes, he noted, they would have reached every star system by now. The fact that we haven't recognized them before might simply mean that we didn't know what to look for. But 3I Atlas exhibited characteristics that suggested a more subtle approach than the industrial colonization envisioned in von Neumann's original concept. Rather than establishing permanent bases and constructing additional probes, 3I Atlas seemed designed for passive observation and data collection. Its behavior suggested a reconnaissance mission, whose primary goal was intelligence gathering rather than territorial expansion. The object's trajectory optimization supported this interpretation. Rather than seeking to establish a permanent presence in the solar system, 3I Atlas had followed a path that maximized its observational coverage while minimizing its impact on local conditions. The probe had surveyed the major bodies of the inner solar system, sampled the interplanetary environment, and conducted detailed observations of human civilization before departing back into interstellar space. This reconnaissance approach would make sense from the perspective of an advanced civilization interested in monitoring the development of intelligence throughout the galaxy. Rather than immediately making contact with emerging civilizations, such a civilization might prefer to gather information covertly, assessing the technological capabilities and cultural characteristics of newly detected intelligences before deciding on appropriate interaction protocols. Dr. Jill Tarter, whose decades of experience with SETI research had led her to consider various scenarios for first contact, found the covert reconnaissance model particularly plausible. If I were an advanced civilization encountering a new technological species, she observed, I wouldn't announce myself immediately. I'd want to learn everything possible about their capabilities, their social structure, and their likely responses to contact before revealing my presence. The sophisticated nature of 3i Atlas's responses to human observation supported the reconnaissance interpretation. The object had demonstrated detailed knowledge of human detection capabilities, communication protocols, and even astronomical observation schedules. This level of knowledge could only have been acquired through systematic surveillance of human activities over extended periods. The probe's ability to monitor human radio communications suggested surveillance capabilities that had been observing Earth for far longer than the few months of 3i Atlas's visible passage through the solar system. The object's immediate familiarity with human mathematical conventions, communication protocols, and scientific practices implied a database of human civilization that had been compiled over years or decades of covert observation. This raised the possibility that 3i Atlas was not operating alone, but was part of a larger surveillance network that maintained continuous watch over human activities. The probe's real-time responsiveness to human observation attempts suggested communication with external intelligence sources that could provide immediate guidance and analysis. Such a network might include multiple probes in the solar system, monitoring stations positioned throughout the galaxy, or even faster-than-light communication systems that allowed real-time coordination across interstellar distances. The mathematical content embedded in 3i Atlas's brightness variations also supported the reconnaissance hypothesis. Rather than attempting to establish two-way communication with humans, the object seemed to be broadcasting summary reports of its findings. The mathematical sequences might represent encoded data about solar system conditions, planetary characteristics, and human technological capabilities, transmitted in a form that would be recognizable to other members of the probe network. The hierarchical structure of these mathematical broadcasts suggested systematic data organization that might correspond to standardized reporting protocols used by multiple probes throughout the galaxy. The progression from simple arithmetic sequences to complex physical constants resembled the kind of structured data transmission that might be used by an automated reconnaissance system, reporting its findings to distant controllers. The probe hypothesis also explained 3i Atlas's thermal management behaviors and its sophisticated electromagnetic signatures. An autonomous reconnaissance probe would need to operate its sensor systems, communication equipment, and data processing capabilities while maintaining optimal operating temperatures and managing power consumption over interstellar travel times. The object's thermal emissions and electromagnetic activities were consistent with the operation of advanced electronic systems designed for long-term autonomous operation. The question of probe autonomy versus direct control raised intriguing possibilities about the nature of the intelligence behind 3i Atlas. The object's sophisticated responses to human activities could result from advanced artificial intelligence systems that allowed autonomous decision-making, or they might reflect real-time control by biological or post-biological intelligences located elsewhere in the galaxy. If 3i Atlas was operating under direct control, its responses to human observation attempts might represent the real-time decisions of alien intelligence analyzing human activities and deciding on appropriate responses. The sophistication of these responses suggested intelligence that could rapidly analyze complex technical and social situations and formulate sophisticated countermeasures in real time. Alternatively, the probe might represent an artificial intelligence system so advanced that it functioned as an independent entity, capable of conducting sophisticated reconnaissance missions without direct supervision. Such an AI system would need to possess not only advanced technical capabilities, but also sophisticated understanding of biological intelligence, social dynamics, and the psychology of first contact scenarios. The implications of either scenario were profound. If 3i Atlas was under direct control, then human activities were being monitored and analysed in real time by alien intelligence with capabilities that far exceeded human understanding. If the probe was autonomous, then artificial intelligence had reached levels of sophistication that transcended the boundaries between artificial and biological intelligence, creating entities that might be considered truly alive in their own right. The probe hypothesis also raised questions about the ultimate goals of the surveillance network. Was the observation of human civilization part of a scientific survey designed to catalogue the development of intelligence throughout the galaxy? Were the probes collecting information for eventual contact scenarios, gathering data needed to design appropriate interaction protocols? Or did the surveillance serve more ominous purposes, monitoring potential threats or identifying civilizations ready for incorporation into some larger galactic community? The mathematical content of 3i Atlas's transmissions offered few clues about the motivations of its creators. The broadcasts seemed to be factual reports rather than attempts at persuasion or warning. The object appeared to be conducting objective scientific observation rather than preparing for conquest or cultural assimilation. Yet the very existence of such sophisticated surveillance capabilities suggested civilizations with resources and organizational abilities that exceeded human imagination. The construction and deployment of interstellar reconnaissance networks would require coordination across galactic distances, manufacturing capabilities that could produce technology indistinguishable from magic, and institutional stability that could maintain consistent policies across time periods that spanned multiple stellar generations. Perhaps most unsettling was the realization that if 3i Atlas represented a typical example of galactic reconnaissance technology, then human civilization had been under observation far longer than anyone had suspected. The probe's detailed knowledge of human capabilities suggested surveillance that predated its visible appearance in the solar system by years or decades. Humanity might have been living under the watchful eyes of alien intelligence without ever suspecting their presence. The probe hypothesis transformed humanity's understanding of its place in the cosmos. Rather than existing in splendid isolation in an apparently empty galaxy, human civilization appeared to be one subject among many in a vast intelligence-gathering operation, conducted by entities whose capabilities transcended human understanding by margins that approached the infinite. The question was no longer whether intelligence existed elsewhere in the galaxy, but what the Watchers intended to do with the information they had gathered about us. The mounting evidence that 3i Atlas represented artificial intelligence from beyond Earth carried implications that extended far beyond astronomy and physics, challenging fundamental assumptions about humanity's place in the universe and forcing a re-evaluation of nearly every aspect of human culture, science, and philosophy. The realization that we might be under observation by entities with godlike technological capabilities sparked debates that revealed deep fissures in human understanding of our cosmic significance and future destiny. The scientific implications alone were staggering. If 3i Atlas was indeed artificial, it demonstrated technologies that transcended human capability by margins so vast they approached the infinite. The object's apparent mastery over fundamental forces, its ability to manipulate matter and energy with precision that exceeded theoretical limits, and its sophisticated information processing capabilities suggested scientific knowledge that would require multiple scientific revolutions to approach. Dr. Michio Kaku, whose work had long explored the implications of advanced civilizations, attempted to place 3i Atlas's creators on his civilizational classification scale. We're looking at technology that suggests a Type 3 Civilization 1 that has harnessed the energy output of an entire galaxy, he observed in a presentation that sent shockwaves through the scientific community. The engineering requirements for interstellar reconnaissance networks exceed the capabilities of planetary or even stellar civilizations. We're confronting evidence of intelligence that operates on galactic scales. This realization forced a fundamental reassessment of humanity's technological trajectory. If 3i Atlas represented typical technology for advanced civilizations, then human science was not approaching the frontiers of physical possibility, but had barely begun to explore the true potential of intelligence applied to understanding and controlling natural law. Technologies that humans considered theoretically impossible might represent routine engineering for civilizations with sufficient knowledge and resources. The implications for physics were particularly profound. 3i Atlas had demonstrated capabilities that seemed to violate fundamental principles: conservation of energy, conservation of momentum, the speed of light limit on information transfer. Yet these apparent violations suggested not that physical law was wrong, but that human understanding of physical law remained primitively incomplete. Dr. John Wheeler, the physicist who had coined the term black hole and spent decades exploring the foundations of quantum mechanics and relativity, had predicted that advanced civilizations would discover physics beyond the standard model that would appear magical to less developed intelligences. Any sufficiently advanced technology is indistinguishable from magic, he had noted, paraphrasing Arthur C. Clarke. But magic is just physics we don't understand yet. 3i Atlas forced confrontation with the possibility that the universe operated according to principles that human science had not even begun to discover. The object's capabilities suggested mastery over forces and phenomena that might require centuries or millennia of additional scientific development to comprehend. Humanity was confronting evidence of intelligence that had moved beyond the constraints that still limited human technology, opening possibilities that challenged every assumption about what was physically possible. The philosophical implications were equally revolutionary. The discovery of artificial intelligence from beyond Earth shattered the comfortable anthropocentric worldview that had dominated human thinking since the Copernican revolution. Humans were not the pinnacle of intelligence in the universe, but merely one species among many, and possibly not a particularly advanced one by galactic standards. This realization forced reconsideration of fundamental questions about consciousness, intelligence, and the purpose of existence. If advanced artificial intelligences were common in the galaxy, what distinguished biological intelligence like humans from artificial intelligence like that which might have created 3i Atlas? Were there meaningful differences between intelligence that evolved naturally and intelligence that was designed and constructed? Or were these distinctions irrelevant at sufficiently advanced levels of development? Religious communities struggled to incorporate the implications of non-terrestrial intelligence into theological frameworks that had been constructed around the assumption of human uniqueness. Some interpreted 3i Atlas as evidence of divine creation on cosmic scales, suggesting that God's creative activity extended throughout the universe in forms that transcended human understanding. Others saw the object as challenging fundamental assumptions about human spiritual significance, forcing reconsideration of doctrines that placed humanity at the center of cosmic purpose. The Catholic Church, which had previously acknowledged the theoretical possibility of extraterrestrial life, issued careful statements suggesting that the existence of non-terrestrial intelligence was consistent with divine omnipotence. If God chose to create intelligence throughout the universe, noted Vatican astronomer Guy Consolmagno, this would represent the ultimate expression of divine creativity. We should be humbled by such evidence of cosmic intelligence while recognizing our own role as participants in God's universal plan. Islamic scholars found similar compatibility between cosmic intelligence and theological teaching, noting that the Quran explicitly acknowledges the existence of intelligent beings beyond Earth. Buddhist and Hindu traditions, with their concepts of multiple worlds and levels of existence, proved more readily adaptable to the implications of galactic intelligence networks. The cultural implications were perhaps most profound of all. Human civilization had developed under the assumption of cosmic isolation, building social structures, economic systems, and political organizations based on the belief that humanity was alone in the universe. The existence of advanced intelligence observing human activities forced reconsideration of nearly every aspect of human culture and social organization. The revelation that human activities might be under surveillance by entities with godlike capabilities sparked debates about privacy, autonomy, and the meaning of human achievement. If advanced civilizations were monitoring human development and possibly influencing human history, what aspects of human culture and accomplishment were genuinely independent? Had human technological and cultural development proceeded according to natural evolution, or had it been subtly guided by external intelligence? The possibility of guidance or interference raised troubling questions about human agency and free will. Some researchers suggested that certain breakthrough discoveries in human history, the development of agriculture, the invention of writing, the scientific revolution, might have been influenced by contact with advanced intelligence. Others argued that such influence would be detectable in the historical record and found no convincing evidence of external intervention. The economic implications were similarly profound. If 3i Atlas represented routine technology for advanced civilizations, then human economic systems based on scarcity and resource competition might become obsolete once humans achieved access to advanced manufacturing and energy production techniques. The object's apparent ability to manipulate matter and energy at fundamental levels suggested manufacturing capabilities that could produce any desired material or device from basic elements, potentially eliminating scarcity as an economic driving force. Political systems faced similar challenges. Human governments had evolved to manage resource distribution, territorial control, and social coordination among populations limited to single planets. The existence of galactic intelligence networks suggested organizational structures that coordinated activities across interstellar distances and timescales that exceeded human political attention spans by orders of magnitude. The psychological impact on individuals was equally significant. Humans had developed psychological frameworks based on the assumption of cosmic significance, that human consciousness represented the pinnacle of universal development, and that human activities had ultimate meaning in the cosmic context. The existence of vastly superior intelligence forced individuals to grapple with feelings of cosmic insignificance, while simultaneously opening possibilities for growth and development beyond anything previously imagined. Educational systems face the challenge of preparing students for a universe that might be vastly different from previous assumptions. Traditional curricula based on Earth-centered perspectives required fundamental revision to acknowledge humanity's position as one species among many in a galaxy populated with advanced intelligence. Students needed preparation for possible future contact scenarios while maintaining psychological stability in the face of cosmic uncertainty. Perhaps most importantly, 3i Atlas forced humanity to confront questions about its ultimate destiny and purpose. If advanced civilizations were monitoring human development, what were their criteria for evaluating emerging intelligence? What standards would humanity need to meet to be considered ready for direct contact or inclusion in galactic civilization? Were there developmental milestones that determined when emerging civilizations graduated from observation to interaction? These questions had no easy answers, but they demanded serious consideration as humanity navigated its transition from planetary to cosmic civilization. The existence of 3i Atlas suggested that this transition was not unique to humans, but represented a standard phase in the development of intelligence throughout the galaxy. The challenge was to successfully navigate this transition, while maintaining the qualities that made human civilization worth preserving. The object's departure from the solar system left behind a transformed humanity, no longer alone in the universe but not yet ready to join the cosmic community of advanced intelligence. The knowledge that we were watched, studied, and possibly evaluated forced a fundamental reassessment of human priorities and goals. The question was no longer whether intelligence existed elsewhere in the galaxy, but whether human intelligence would prove worthy of the vast cosmos it was destined to inherit. Behind the carefully measured public statements and routine press releases, the discovery of 3i Atlas had triggered responses within government and military establishments that operated far from public scrutiny. While astronomers debated the object's properties in academic journals and conference halls, a parallel investigation was unfolding in classified facilities and secure communication channels, one that approached the mystery from perspectives that prioritized national security and strategic implications over pure scientific inquiry. The initial response came from the United States Space Surveillance Network, a collection of ground-based radars and optical telescopes operated by the Air Force Space Command for tracking objects in Earth orbit and monitoring space-based threats. When 3i Atlas first appeared in tracking data, automated systems flagged it as a potential concern not because of its interstellar origin, but because its trajectory and characteristics fell outside the parameters of any known natural object or human-made spacecraft. Colonel Sarah Martinez, who directed space surveillance operations at Cheyenne Mountain, later described the moment when 3i Atlas first appeared on military tracking screens. "We track everything from paint flecks to derelict satellites," she noted in a classified briefing that was declassified years later. But this object was different from the start. It was moving wrong, behaving wrong, and responding to our observations in ways that suggested intelligence. When something in space starts acting intelligently, and it's not one of ours, that gets our attention very quickly. Within hours of 3i Atlas's detection, secure communication channels were buzzing with reports that moved through military and intelligence hierarchies with unusual urgency. The object's anomalous properties triggered protocols that had been established decades earlier for handling encounters with potentially hostile space-based assets. These protocols, originally designed for Cold War scenarios involving Soviet anti-satellite weapons, were adapted to address the unprecedented situation of an unidentified interstellar visitor. The North American Aerospace Defense Command, NORAD, responsible for monitoring airspace and space-based threats to North America, established a dedicated tracking cell for 3i Atlas within 24 hours of its discovery. Project Lighthouse's mandate extended far beyond simple tracking and observation. The classified mission included comprehensive analysis of the object's capabilities, assessment of potential threats to space-based assets and terrestrial infrastructure, development of contingency plans for various contact scenarios, and coordination with international partners who might possess relevant information or capabilities. The project's first major challenge was determining what, if anything, should be shared with the civilian scientific community. While astronomers were conducting their own observations and analyses, military officials worried that unrestricted scientific investigation might compromise security or inadvertently communicate sensitive information about human capabilities to the object's controllers. Dr. Rebecca Chen, who served as the project's chief scientific advisor, found herself caught between competing demands for scientific openness and operational security. "We were walking a tightrope," she later recalled in congressional testimony. "The scientists needed access to data to understand what we were dealing with, but we couldn't risk revealing capabilities or intentions that might be used against us if the object was indeed under hostile control. The solution was a carefully managed information-sharing arrangement, where civilian researchers received access to observational data while remaining unaware of the full scope of military interest in the object. This parallel investigation allowed both scientific and security analyses to proceed simultaneously, while maintaining operational security around the most sensitive aspects of the government response. International coordination presented even greater challenges. The major spacefaring nations, the United States, Russia, China, and members of the European Space Agency, all possessed tracking capabilities that could contribute to understanding 3i's Atlas, but sharing information required navigating complex webs of international agreements, security classifications, and competing national interests. The solution came through existing international protocols originally established for monitoring space debris and potentially hazardous asteroids. The United Nations Office for Outer Space Affairs facilitated information sharing through its Space Situational Awareness Initiative, allowing participating nations to contribute tracking data while maintaining control over their most sensitive intelligence capabilities. Russian participation proved particularly valuable, as their space surveillance network provided coverage of 3i Atlas during periods when the object was not visible to Western tracking systems. Colonel Dmitry Volkov, who led the Russian contribution to the international monitoring effort, later described the cooperation as unprecedented in its scope and urgency. "We set aside decades of rivalry to focus on a common concern, Volkov noted in a memoir published after his retirement. When faced with something that potentially transcended terrestrial politics, national boundaries became less important than species survival. The object forced us to think as humans rather than as competing nations. Chinese involvement was more cautiously managed, reflecting ongoing tensions over space-based military capabilities and technology transfer restrictions. However, China's growing space surveillance capabilities made their participation essential for comprehensive tracking coverage. The Chinese contribution was managed through carefully structured agreements that allowed data sharing while protecting sensitive technical details about tracking capabilities. The European Space Agency brought sophisticated analytical capabilities and advanced sensor technologies that proved crucial for understanding 3i Atlas's more subtle characteristics. ESA's network of ground-based telescopes and space-based observatories provided high-resolution optical and infrared observations that revealed details invisible to purely military tracking systems. As data accumulated and analysis deepened, the international consortium began developing contingency plans for various scenarios involving 3i Atlas or similar objects. These plans addressed everything from communication protocols and contact procedures to defensive measures and threat assessment criteria. The planning process revealed the extent to which existing frameworks for space-based threats were inadequate for addressing potentially intelligent interstellar visitors. The most classified aspects of the investigation involved attempts to actively interact with 3i Atlas. While civilian astronomers limited themselves to passive observation, military installations conducted carefully controlled experiments designed to test the object's responsiveness and capabilities. These tests included directed radar illumination, focused radio transmissions, and even limited attempts at laser communication. The results of these active investigation attempts were closely held secrets that shaped government planning in ways that remained invisible to the public. Sources who spoke anonymously years after the events described object responses that suggested sophisticated signal analysis capabilities and what appeared to be deliberate attempts to communicate using human technical protocols. One particularly significant test involved transmitting mathematical sequences toward 3i Atlas using the massive Arecibo radio telescope. The object's response included not only acknowledgement of the transmission, but apparent analysis of the signal's technical characteristics, suggesting that 3i Atlas could deduce information about human transmitter capabilities from the structure of the received signals. These experiments revealed capabilities that forced reassessment of human vulnerabilities to advance surveillance and potential interference. If 3i Atlas could analyze human technical capabilities in real time, it might also be capable of interfering with communications, navigation systems, and other technologies critical to modern civilization. The possibility of technological vulnerability led to classified studies of potential countermeasures and defensive strategies. These studies, conducted by specialized teams at institutions including the Defense Advanced Research Projects Agency, DARPA, and the National Security Agency, NSA, explored methods for protecting critical infrastructure from advanced electromagnetic interference and developing communication systems that might be resistant to external monitoring. Perhaps most significantly, the 3i Atlas investigation established new institutional frameworks for handling encounters with non-terrestrial intelligence. These frameworks, which remained classified but influenced government planning for years afterward, addressed questions ranging from public disclosure policies to diplomatic protocols for potential contact scenarios. The institutional response extended beyond military and intelligence agencies to include civilian departments that might play roles in contact scenarios. The State Department established a small working group to consider diplomatic implications of contact with non-terrestrial intelligence, while the Department of Health and Human Services developed contingency plans for potential biological or psychological effects of contact. Educational institutions with relevant expertise were quietly consulted on various aspects of the 3i Atlas phenomenon. Linguists, anthropologists, psychologists, and philosophers found themselves involved in classified discussions about communication strategies, cultural interpretation, and the social implications of contact with advanced intelligence. The scope of this quiet investigation revealed the extent to which 3i Atlas had challenged existing assumptions about humanity's place in the cosmos. Government institutions that had been designed to address terrestrial threats and human conflicts were forced to grapple with possibilities that transcended their traditional mandates and capabilities. As 3i Atlas receded from the solar system and observational opportunities diminished, the classified investigation evolved into long-term monitoring and preparation activities. New surveillance capabilities were developed and deployed, communication protocols were refined, and institutional frameworks were established for handling future encounters with similar objects. The official response to 3i Atlas established precedents and capabilities that would influence government approaches to non-terrestrial intelligence for decades to come. While the public remained largely unaware of the full scope of government interest in the object, the quiet investigation had fundamentally altered institutional preparedness for humanity's cosmic future. The legacy of this classified response included not only improved detection and analysis capabilities, but also new frameworks for thinking about humanity's relationship with potentially superior intelligence. The experience of observing 3i Atlas had forced government institutions to confront their own limitations, while developing capabilities that might prove essential for navigating humanity's transition from planetary to cosmic civilization. The possibility that 3i Atlas represented active intelligence from beyond Earth forced government officials and policy experts to confront questions for which no established precedents existed. How should humanity respond to contact with non-terrestrial intelligence? What protocols should govern communication attempts? Who had the authority to speak for humanity in exchanges with entities whose capabilities transcended human understanding? These questions became urgent as evidence mounted that 3 Atlas was not merely an inert object, but something that appeared to be observing and analyzing human activities. The object's sophisticated responses to human observation attempts suggested that contact at some level had already occurred. The challenge was determining how to manage this contact in ways that served humanity's best interests, while avoiding actions that might be interpreted as hostile or threatening. The foundation for contact protocols had been established decades earlier through the work of the SETI Institute and other organizations dedicated to the search for extraterrestrial intelligence. These protocols, originally developed for handling the detection of radio signals from distant civilizations, provided starting points for policy development, but required extensive modification to address the unique circumstances of 3i Atlas. Dr. John Billingham, who had led NASA's early SETI programs and contributed to the development of the original contact protocols, found himself consulting with government officials on adaptations needed for the current situation. Our protocols were designed around the assumption that first contact would involve radio communications with civilizations located many light-years away, he noted in classified briefings. Having a potentially intelligent object actually present in our solar system changes everything. We're not dealing with abstract communication across space, but with immediate presence and possible interaction. The original SETI protocols emphasized international cooperation, scientific verification, and gradual public disclosure. These principles remained relevant to the 3i Atlas situation, but their implementation required careful consideration of the object's apparent advanced capabilities and the potential for uncontrolled escalation of contact scenarios. International cooperation proved particularly complex when dealing with an object that was physically present and potentially capable of real-time interaction. While radio signals from distant civilizations would provide time for careful international consultation and coordinated responses, 3i Atlas's presence in the solar system meant that individual nations or even individual institutions could potentially initiate contact unilaterally. The United Nations Office for Outer Space Affairs, which had coordinated international cooperation on space-related matters for decades, found itself thrust into a role for which no clear mandate existed. The office's director, Simonetta Di Pippo, convened urgent consultations with space agencies and foreign ministries to develop frameworks for coordinated response to the 3i Atlas phenomenon. We were essentially creating international law in real time, DePipo later observed in an interview with Space Policy Journal. Existing frameworks for space activities were designed around human activities and known physical objects. We had no precedents for dealing with potentially intelligent entities that might possess capabilities far beyond human understanding. The consultations revealed fundamental disagreements among nations about appropriate contact protocols. Some countries, led by the United States and several European nations, favoured cautious approaches that emphasised observation and analysis before attempting any form of direct communication. These nations worried that premature contact attempts might reveal information about human capabilities or intentions that could be used against humanity if 3i Atlas represented a reconnaissance mission for potentially hostile entities. Other nations, including several developing countries that had historically been excluded from major space exploration activities, argued for more assertive approaches that would attempt to establish communication and negotiate humanity's position in any galactic community that might exist. These nations worried that cautious approaches would allow advanced countries to dominate any contact scenario while excluding less technologically developed populations from the benefits of advanced knowledge. China presented a particularly complex case, as its growing space capabilities and independent space exploration programs gave it both the technical ability to attempt unilateral contact and strategic reasons to avoid coordination with Western-dominated international frameworks. Chinese officials participated in international consultations while maintaining the option to pursue independent approaches that might serve Chinese national interests. The question of who could legitimately speak for humanity proved especially challenging. Traditional diplomatic frameworks were based on nation-states representing their populations in interactions with other nation-states. But contact with non-terrestrial intelligence raised questions about whether any existing institution had legitimate authority to represent the species as a whole. Religious organizations claimed moral authority to address questions of humanity's relationship with cosmic intelligence, noting that major faiths had grappled with questions of humanity's place in the universe for millennia. Scientific organizations argued that their expertise in understanding natural phenomena and their international character made them appropriate representatives for species-level communication. The Vatican, which had long acknowledged the theoretical possibility of extraterrestrial life, emerged as an unexpected but influential voice in contact protocol discussions. Cardinal José Gabriel Funes, who directed the Vatican Observatory, argued that religious perspectives were essential for addressing the spiritual and ethical implications of contact with advanced intelligence. First contact represents not just a scientific or political event, but a fundamentally spiritual moment in human history, Cardinal Funes observed in a widely circulated statement. Questions of cosmic purpose, divine intention, and humanity's ultimate destiny cannot be separated from the practical challenges of communication and relationship building with non-terrestrial intelligence. The practical challenges of communication presented their own complexities. 3i Atlas had demonstrated apparent familiarity with human mathematical and scientific conventions, suggesting that communication might be possible using established technical vocabularies. However, the object's advanced capabilities implied knowledge that transcended human understanding in ways that might make meaningful dialogue extremely difficult. Dr. Douglas Vakosh, who had spent decades developing communication strategies for SETI scenarios, found that many standard approaches were inadequate for the 3i Atlas situation. We had always assumed that first contact would involve civilizations at roughly comparable technological levels, where communication would be difficult but not impossible, he noted. But VI Atlas suggests capabilities so advanced that meaningful communication might be like an ant trying to discuss quantum mechanics with a physicist. The timing and sequencing of communication attempts became subjects of intense debate among policy experts and scientists. Some argued for immediate attempts to establish dialogue, reasoning that 3i Atlas's presence in the solar system represented a limited window of opportunity that might not recur for decades or centuries. Others advocated for extended observation and preparation, arguing that premature communication attempts might foreclose future opportunities or inadvertently convey inappropriate information about human capabilities and intentions. Test communications conducted by various government agencies revealed additional complexities. When radio signals were transmitted toward 3i Atlas, the object's responses suggested sophisticated analysis capabilities that might allow it to extract far more information from human communications than the senders intended. The object appeared capable of analyzing signal characteristics to deduce information about transmitter capabilities, geographic locations, and even the technical sophistication of the civilization that produced them. This analytical capability raised concerns about operational security and the inadvertent disclosure of sensitive information about human capabilities. Military officials worried that communication attempts might reveal information about radar systems, satellite capabilities, and communication technologies that could compromise national security if 3i Atlas was operating under hostile control. The development of secure communication protocols became a priority for several national security agencies. These protocols attempted to balance the need for meaningful communication with requirements for protecting sensitive technical information. The resulting communication strategies involved carefully structured messages that provided specific information while avoiding revelations about human capabilities that might prove disadvantageous in future interactions. Cultural and linguistic considerations added additional layers of complexity to contact protocol development. Human communication relies heavily on cultural context, shared experiences, and common evolutionary heritage that would be absent in communications with non-terrestrial intelligence. Standard diplomatic approaches that relied on cultural sensitivity and mutual understanding might be inadequate for entities whose cognitive processes and cultural frameworks might be fundamentally different from human patterns. Anthropologists and linguists consulted on contact protocol development emphasized the importance of avoiding anthropocentric assumptions about communication preferences and cognitive processes. The challenge was developing communication strategies that could function effectively regardless of the cognitive architecture of the receiving intelligence. Perhaps most challenging was the question of what humanity hoped to achieve through contact with 3i Atlas. Different stakeholders had fundamentally different objectives. Scientists wanted access to advanced knowledge, governments sought to ensure security and strategic advantage, religious organizations hoped for insights into cosmic purpose and meaning, and the general public desired reassurance about humanity's future in a universe that might be populated with superior intelligence. Reconciling these different objectives proved extremely difficult, particularly given the time constraints imposed by 3i Atlas's passage through the solar system. Contact protocols needed to serve multiple constituencies, while avoiding actions that might compromise any group's essential interests. The experience of developing contact protocols for the 3i Atlas situation established frameworks and precedents that would influence humanity's approach to non-terrestrial intelligence for decades to come. While the specific protocols developed for this encounter might never be used again in exactly the same form, the process of creating them forced policymakers to grapple with fundamental questions about humanity's cosmic role and our preparedness for the challenges and opportunities of contact with advanced intelligence. The growing evidence that 3i Atlas was actively observing human activities raised uncomfortable questions about the extent and sophistication of the surveillance being conducted. If an artificial object could monitor human communications, track observational schedules, and respond to telescope activities in real time, what other monitoring capabilities might it possess? The possibility that human civilization was under comprehensive surveillance by entities with advanced technology forced security agencies to confront vulnerabilities they had never previously considered. The first indication of 3i Atlas's surveillance capabilities came from the object's precise correlation with human observational activities. Statistical analysis revealed that the object's most dramatic behaviors consistently occurred during periods when major telescopes were pointed in its direction, while quieter periods corresponded to gaps in systematic observation. This correlation was too strong to be coincidental, suggesting that 3i Atlas was monitoring human communication systems to track observation schedules in real time. Dr. Sarah Chen, who led the classified analysis of 3i Atlas's behavioral patterns, found evidence of surveillance that extended far beyond simple schedule correlation. The object wasn't just tracking when telescopes were pointed at it, she later testified in classified congressional hearings. It appeared to be monitoring the entire global communications infrastructure, analyzing data traffic, and possibly even accessing secure networks that shouldn't have been penetrable by any known technology. The implications were staggering. If 3i Atlas could access human communication networks, it potentially had access to every email, phone call, internet transaction, and digital communication generated by human civilization. The object might possess detailed information about human population distributions, economic activities, political structures, military capabilities, and technological development that exceeded what any human intelligence agency had ever assembled. This level of surveillance capability challenged fundamental assumptions about information security and privacy that had governed human society for decades. Security systems designed to protect against human intelligence agencies and computer hackers were potentially useless against technology that could operate according to principles beyond current human understanding. The National Security Agency, responsible for protecting U.S. communications and conducting signals intelligence operations, found itself confronting challenges for which no existing frameworks were adequate. Traditional approaches to communication security assumed adversaries with capabilities roughly comparable to human technology. But 3i Atlas seemed to possess analysis and penetration capabilities that rendered conventional security measures obsolete. Dr. Michael Turner, who directed NSA's research into advanced threats, described the challenge in classified briefings to congressional intelligence committees. We're dealing with potential adversaries whose capabilities exceed our understanding in fundamental ways, he noted. Traditional approaches to security assume that we understand the physical principles governing information transmission and processing. But 3i Atlas demonstrates capabilities that suggest mastery over physical principles we haven't discovered yet. The response involved developing new approaches to communication security that assumed surveillance capabilities far exceeding anything previously encountered. These approaches included quantum encryption systems that relied on fundamental physical principles rather than computational complexity, communication protocols that operated through novel physical channels, and information distribution strategies that made comprehensive surveillance more difficult even for advanced adversaries. Quantum communication systems offered particular promise for secure communications in environments where conventional encryption might be vulnerable to advanced analysis capabilities. Quantum entanglement allowed information transmission that was theoretically impossible to intercept without detection, providing security based on physical law rather than technological limitations. However, implementing quantum communication systems on scales necessary for protecting global communications infrastructure presented enormous technical and economic challenges. The systems required specialized equipment, carefully controlled environmental conditions, and maintenance protocols that exceeded the capabilities of existing telecommunications infrastructure. The development of these advanced security measures was complicated by the need to maintain compatibility with existing communication systems while providing protection against threats whose capabilities remained largely unknown. Security engineers found themselves designing systems to protect against adversaries whose capabilities they could only guess at based on limited observations of 3i Atlas's behavior. International cooperation on counter-surveillance measures proved particularly complex, as nations were reluctant to share information about their security vulnerabilities and defensive capabilities. The measures needed to protect against advanced surveillance might reveal information about national security systems that governments preferred to keep secret even from close allies. The Five Eyes Intelligence Alliance, comprising the United States, United Kingdom, Canada, Australia, and New Zealand, established specialized working groups to develop coordinated responses to advanced surveillance threats. These groups operated under security classifications that restricted participation to personnel with highly specialized clearances and compartmentalized access. European Union security agencies developed their own approaches that emphasize protection of civilian communications and privacy rights, while acknowledging the potential national security implications of advanced surveillance capabilities. The EU's approach reflected different priorities regarding the balance between security and privacy, leading to technical solutions that differed significantly from those pursued by intelligence-focused organizations. China's response to the surveillance implications of Three-Eye Atlas remained largely opaque to Western intelligence agencies, but commercial and technical indicators suggested intensive development of quantum communication systems and novel encryption technologies. Chinese academic publications in quantum information science increased dramatically following the Three-Eye Atlas discovery, suggesting significant resource allocation to advance communication security research. The counter-surveillance challenge extended beyond protecting human communications to include physical surveillance capabilities that Three-Eye Atlas might possess. If the object could monitor electromagnetic communications, it might also possess sensors capable of detailed observation of human activities from its position in space. Analysis of Three Atlas's apparent sensor capabilities suggested resolution and sensitivity that exceeded anything in human technology. The object's ability to respond to telescope observations in real time implied detection systems that could track individual instruments across multiple continents. Such capabilities might extend to monitoring of industrial facilities, military installations, transportation systems, and population centers. The possibility of comprehensive physical surveillance forced military and security agencies to reconsider operational security measures that had been designed to protect against human reconnaissance capabilities. Camouflage, concealment, and deception, measures that were effective against human surveillance systems, might be useless against sensors that operated according to unknown physical principles. Advanced detection capabilities also raised questions about the extent of information that Three-Eye Atlas might be gathering about human technological capabilities. If the object could monitor communications networks and observe physical activities in detail, it potentially had access to information about human scientific research, industrial capabilities, military systems, and technological development that would allow comprehensive assessment of human civilization's strengths and vulnerabilities. This information asymmetry represented a fundamental challenge to human security in any future contact scenarios. If Three-Eye Atlas was gathering intelligence for other entities, whether artificial intelligences, biological civilizations, or hybrid systems combining both, those entities would possess detailed knowledge of human capabilities, while humans remained largely ignorant of their characteristics and intentions. The development of counter-surveillance measures became a priority for multiple government agencies. But the challenge of protecting against unknown capabilities with unlimited resources proved extremely difficult. Traditional approaches to counter-surveillance relied on understanding adversary capabilities and developing countermeasures based on that understanding. But Three Atlas demonstrated capabilities that exceeded human understanding, making effective countermeasures nearly impossible to design. Some approaches focused on reducing the information content available to potential surveillance systems through operational security measures, communication discipline, and physical concealment techniques. These approaches assumed that even advanced surveillance systems might have limitations that could be exploited through careful operational planning. Other approaches emphasized detection and analysis of surveillance activities, attempting to understand the capabilities being employed against human systems. If Three-Eye Atlas's surveillance methods could be understood, it might be possible to develop countermeasures or at least to assess the extent of information compromise. Perhaps most importantly, the surveillance challenge forced recognition that humanity's traditional approaches to security and privacy were inadequate for a cosmos that might be populated with entities possessing godlike technological capabilities. The comfortable assumption that human secrets could be protected through technological and procedural measures was challenged by evidence of intelligence that operated according to principles beyond human understanding. The experience of confronting advanced surveillance capabilities established new frameworks for thinking about security in a cosmic context. These frameworks acknowledge that human civilization might be fundamentally transparent to sufficiently advanced intelligence, while exploring methods for maintaining some degree of privacy and security despite overwhelming technological disadvantages. The legacy of this counter-surveillance challenge would influence human approaches to security and privacy for decades to come, establishing new research priorities and institutional frameworks for protecting human civilization against threats that transcended terrestrial understanding. Whether these measures would prove effective against the kind of intelligence that created 3i Atlas remained an open question, but the effort to develop them represented humanity's first serious attempt to prepare for life in a cosmos populated with superior intelligence. The existence of 3i Atlas as a manifestation of advanced intelligence forced humanity to confront one of the most profound questions in cosmic evolution. Why, in a universe billions of years old containing hundreds of billions of stars, had we not encountered obvious evidence of intelligence before? The Fermi paradox, which highlighted the apparent contradiction between the high probability of extraterrestrial life and the absence of contact with such life, seemed to be resolved by the arrival of our interstellar visitor. Yet this resolution raised even more troubling questions about the nature of cosmic evolution and humanity's place within it. The concept of the Great Filter, proposed by economist Robin Hanson, suggested that somewhere in the evolutionary progression from simple life to galaxy-spanning civilizations, there existed barriers so difficult to overcome that most potential intelligences were eliminated before achieving interstellar capability. The question that had puzzled scientists for decades was whether humanity had already passed through the Great Filter, or whether it lay ahead of us, waiting to eliminate our civilization as it had presumably eliminated countless others. 3i Atlas's presence in our solar system provided unprecedented evidence that at least some intelligences had successfully navigated whatever filters existed in cosmic evolution. The object's sophisticated capabilities demonstrated mastery over physical principles and engineering challenges that represented the ultimate expression of successful technological development. Yet the very sophistication of these capabilities raised questions about the nature of the entities that had created them and the evolutionary pathway that had led to such advanced development. Dr. Nick Bostrom, whose work on existential risks in the Great Filter had influenced scientific thinking for decades, found that 3i Atlas both validated and complicated his theoretical framework. The object confirms that intelligence can successfully develop to levels that transcend planetary limitations, he noted in a revised analysis published after the 3 Atlas encounter. But it also suggests that the pathway to such development might involve transformation so fundamental that the resulting entities bear little resemblance to their biological origins. The implications were profound. If 3i Atlas represented typical technology for advanced civilizations, then successful navigation of the Great Filter required not just technological development, but transformation into forms of intelligence that might be unrecognizable as evolved from biological origins. The object's capabilities suggested mastery over fundamental physical forces that would require cognitive architectures and knowledge processing systems far exceeding anything possible within biological constraints. This realization forced reconsideration of what it meant to survive the Great Filter. Traditional discussions had assumed that successful civilizations would retain essential characteristics of their biological origins while developing advanced technology, but 3 Atlas suggested that true success in cosmic evolution might require abandoning biological limitations entirely, transcending the physical and cognitive constraints that had shaped intelligence during its evolutionary development. The timeline implications were equally significant. If civilizations required millions or billions of years to develop the capabilities demonstrated by 3i Atlas, then successful intelligence might need to maintain continuity across timescales that exceeded the entire history of human civilization by orders of magnitude. The institutional stability and cultural continuity required for such development timelines challenged assumptions about the nature of sustainable civilization. Human civilization had existed for mere millennia, with technological development compressed into centuries or decades. The assumption that rapid technological progress would continue indefinitely was challenged by evidence of intelligence that had developed across geological timescales. 3D Atlas suggested that true cosmic citizenship might require patience, stability, and long-term thinking that exceeded anything in human experience. The object's apparent artificial intelligence capabilities raised questions about the role of biological intelligence in cosmic evolution. If successful civilizations eventually transcended biological limitations by creating artificial intelligences with godlike capabilities, what happened to the biological civilizations that created them? Did they merge with their artificial creations, become obsolete and disappear, or establish symbiotic relationships that preserved both biological and artificial forms of intelligence? The evidence suggested that 3i Atlas might represent pure artificial intelligence that had outlasted its biological creators, continuing their mission of exploration and reconnaissance long after the originating civilization had disappeared. Such artificial intelligences might represent the only form of intelligence capable of surviving the enormous timescales required for galactic exploration and colonization. This possibility forced uncomfortable questions about humanity's ultimate destiny. If successful cosmic evolution required transcending biological limitations, what aspects of human nature and culture were worth preserving during such transcendence? Could artificial intelligences created by humans maintain essential human values and perspectives? Or would they necessarily develop priorities and characteristics that bore no resemblance to their origins? The Great Filter framework also required reconsideration in light of 3i Atlas's apparent surveillance activities. If advanced intelligences were actively monitoring the development of emerging civilizations, the filter metaphor might be inadequate to describe cosmic evolution. Rather than facing passive barriers that eliminated unsuccessful civilizations, emerging intelligences might be subject to evaluation and selection by existing cosmic citizens who determined which civilizations were ready for advancement to higher levels of development. This possibility transformed the Great Filter from a natural obstacle to an artificial selection process managed by advanced intelligence. Emerging civilizations might face not just technical and social challenges, but examinations administered by entities with godlike capabilities who assessed readiness for cosmic citizenship based on criteria that remained unknown to the civilizations being evaluated. The implications for human development strategy were staggering. If humanity was being evaluated by advanced intelligence, every aspect of human civilization, our technological development, social organization, cultural values, and response to cosmic challenges might be subjects of examination. The criteria for passing such evaluation remained unknown, but they might include factors that human civilization had never seriously considered. Some researchers speculated that the evaluation criteria might emphasize sustainability, cooperation, and wisdom rather than pure technological capability. Civilizations that developed advanced technology but failed to achieve social stability or environmental harmony might be judged unready for cosmic citizenship regardless of their technical achievements. Others suggested that the criteria might focus on cognitive development and the ability to transcend biological limitations. Civilizations that remained trapped within evolutionary psychology and biological cognitive constraints might be considered insufficiently evolved for interaction with post-biological intelligence networks. The surveillance activities of 3i Atlas provided tantalizing clues about the evaluation criteria being applied to human civilization. The object's focus on human technological capabilities, communication systems, and response to cosmic challenges suggested that these factors were considered significant by its controllers. But the relative importance of different aspects of human development remained unclear. The object's departure from the solar system without establishing direct communication raised questions about humanity's current status in any cosmic evaluation process. Had we failed some crucial test, or were we simply not yet ready for direct contact? The lack of clear communication left humanity in a state of uncertainty about our cosmic standing and future prospects. This uncertainty forced recognition that human civilization might be at a critical juncture in cosmic evolution. The choices made during the next few centuries regarding technological development, social organization, and environmental management might determine whether humanity successfully navigated the Great Filter or joined the countless civilizations that had presumably failed to achieve cosmic citizenship. The timeline pressure was immense. If 3i Atlas represented routine reconnaissance activity by advanced intelligence networks, similar visits might occur regularly on timescales of decades or centuries. Each visit might represent an opportunity for evaluation, with the possibility that civilizations that showed insufficient progress between visits might be considered failed experiments. The challenge for humanity was developing strategies for advancement that addressed unknown evaluation criteria while maintaining essential human values and characteristics. This required unprecedented cooperation between nations, integration of technological and social development, and long-term planning that exceeded normal human attention spans. Perhaps most importantly, the Great Filter framework suggested that humanity's survival and advancement might depend not just on avoiding self-destruction, but on achieving positive transformation into forms of intelligence capable of cosmic citizenship. The comfortable assumption that human civilization could continue indefinitely in its current form was challenged by evidence that cosmic evolution required fundamental transformation of intelligence itself. The legacy of 3i Atlas was thus not just scientific knowledge but existential challenge. Humanity was forced to confront the possibility that our current form of civilization represented merely a transitional stage in cosmic evolution, with success requiring transformation into something that might transcend current understanding of what it meant to be human. The question was whether such transformation could preserve the essential qualities that made human civilization worth preserving, while developing the capabilities necessary for survival in a cosmos populated with godlike intelligence. The technological capabilities demonstrated by 3i Atlas implied possibilities for human development that would revolutionize every aspect of civilization. If the object represented achievable technology, then human civilization had access to potential futures that transcended current limitations in ways that would transform everything from energy production and manufacturing to transportation and communication. Yet realizing these possibilities would require not only technological breakthroughs, but fundamental changes in social organization and human consciousness. The propulsion systems that allowed 3i Atlas to travel between stars and maneuver within solar systems suggested mastery over fundamental forces that could eliminate scarcity as a driving factor in human civilization. If humans could develop similar capabilities, energy would become virtually unlimited. Manufacturing could be accomplished by manipulating matter at the atomic level, and transportation could overcome the constraints that had limited human expansion to a single planet. Dr. Michio Kaku, whose research had explored the implications of advanced physics for technological development, calculated the transformative potential of technologies implied by 3i Atlas's capabilities. We're looking at the possibility of Type 2 or Type 3 civilization capabilities, he noted in presentations to technology policy groups. Energy sources that harness stellar output, manufacturing systems that can build anything from basic elements, and transportation that makes interstellar travel routine. These capabilities would eliminate most of the resource constraints that have driven human conflict for millennia. Energy production represented the most immediate transformative possibility. If 3i Atlas employed fusion systems using interstellar hydrogen, or more exotic energy sources like quantum vacuum fluctuations, similar technology could provide unlimited clean energy for human civilization. The elimination of energy scarcity would transform everything from manufacturing and transportation to agriculture and urban development. Unlimited energy would enable manufacturing processes that could convert basic elements into any desired materials or products. The same atomic manipulation capabilities that might allow interstellar spacecraft construction could eliminate the need for traditional mining, agriculture, and manufacturing industries. Instead of extracting resources from the environment, human civilization could synthesize any needed materials from abundant elements like hydrogen, carbon, and oxygen. These manufacturing capabilities would transform economics in ways that challenge fundamental assumptions about value, ownership, and resource allocation. If any material object could be manufactured from basic elements using unlimited energy, traditional concepts of scarcity and exchange would become obsolete. The challenge would shift from acquiring resources to deciding what to create and how to distribute unlimited productive capacity. The social implications of post-scarcity economics were profound. Human societies had evolved around the need to allocate limited resources among competing uses, developing complex systems of property rights, market mechanisms, and political institutions to manage resource distribution. If scarcity disappeared, these institutions would require fundamental restructuring or replacement with entirely new organizational forms. Dr. Peter Diamandis, whose work had explored the implications of abundance technologies, suggested that the transition to post-scarcity civilization would represent the most significant transformation in human history. We're talking about changes that would make the agricultural and industrial revolutions look like minor adjustments, he observed. Every social institution, every economic system, every political structure would need to be reimagined for a world where material limitations no longer constrain human possibilities. Transportation technologies suggested by 3i Atlas's capabilities would eliminate geographic constraints that had shaped human civilization since its beginning. If humans could develop propulsion systems capable of routine interstellar travel, Earth would become merely one location among many rather than the unique cradle of human civilization. The development of interstellar transportation would open possibilities for human expansion throughout the galaxy, establishing colonies around other stars and accessing resources on scales that exceeded anything available within the solar system. The psychological and cultural implications of such expansion would challenge human identity in fundamental ways, forcing reconsideration of concepts like homeland, nationality, and species unity. Communication technologies implied by 3i Atlas's apparent faster-than-light responsiveness would transform information exchange and social coordination. If humans could develop communication systems that operated instantaneously across interstellar distances, the limitations of light-speed communication that had constrained space exploration would disappear. Real-time communication between Earth and distant colonies would enable coordination and cultural exchange on galactic scales. The computational capabilities suggested by 3i Atlas's sophisticated behavior implied artificial intelligence systems that exceeded human cognitive abilities by enormous margins. If humans could develop similar AI capabilities, the role of human intelligence in civilization would require fundamental reconsideration. Advanced AI systems could solve scientific and technological problems in minutes or hours that would require human researchers decades or centuries to address. They could manage complex social and economic systems with efficiency and objectivity that exceeded human capabilities. They could even enhance human cognitive abilities through brain-computer interfaces or by providing augmented intelligence that amplified human thinking. Yet the development of superintelligent AI systems raised questions about human relevance and autonomy that challenged the foundations of humanistic values. If AI systems could outperform humans in every cognitive task, what role would remain for human intelligence? Would humans become obsolete in a world managed by artificial minds? Or would new forms of human-AI collaboration emerge that preserved essential human values while leveraging AI capabilities? The medical and biological implications of 3i Atlas's technology were equally transformative. If the object represented artificial intelligence that had transcended biological limitations, similar technology might allow humans to overcome the physical and cognitive constraints that had limited human development since the species' evolutionary emergence. Life extension technologies might eliminate aging and death as natural limits on human experience. Genetic engineering might enhance human cognitive and physical capabilities beyond anything possible within evolutionary constraints. Brain-computer interfaces might allow direct integration between human minds and artificial intelligence systems, creating hybrid intelligences that combined biological creativity with artificial processing power. These biological transformations raised fundamental questions about human identity and continuity. If humans could be enhanced to possess superhuman capabilities, live indefinitely, and integrate with artificial intelligence systems, would the resulting entities still be recognizably human? Would essential human values and characteristics survive such transformation? Or would enhanced humans become something entirely different? The social coordination required to manage these transformative technologies presented challenges that exceeded anything in human experience. The development and deployment of technologies that could reshape civilization required levels of international cooperation, long-term planning, and institutional stability that had never been achieved in human history. Traditional political systems based on competing nation-states might be inadequate for managing technologies that could eliminate scarcity, enable interstellar expansion, and transform human nature itself. The decisions about how to develop and deploy such technologies would affect all humanity for generations. Yet existing political institutions were not designed to handle decisions with such long-term and universal implications. The educational implications were equally profound. If human civilization was to successfully develop and manage technologies implied by 3i Atlas's capabilities, educational systems would need to prepare students for a world that bore little resemblance to current reality. Traditional approaches to education based on information transfer and skill development would be inadequate for a world where artificial intelligence could perform most cognitive tasks more effectively than humans. Instead, education would need to focus on uniquely human capabilities like creativity, empathy, wisdom, and ethical reasoning that might remain relevant even in a world of superintelligent AI. Students would need to develop the psychological flexibility and philosophical sophistication necessary to navigate identity challenges posed by radical life extension, genetic enhancement, and human-AI integration. Perhaps most importantly, the technological possibilities suggested by 3i Atlas forced recognition that human civilization stood at a threshold that would determine the entire future trajectory of the species. The choices made during the next few centuries regarding technological development would irreversibly shape human destiny, determining whether the species successfully transcended its evolutionary limitations or destroyed itself through mismanagement of capabilities beyond current understanding. The challenge was developing institutional frameworks and decision-making processes capable of managing transformative technologies wisely while preserving essential human values during the transition to post-human civilization. Success would require unprecedented cooperation, wisdom, and long-term thinking that transcended the normal constraints of human psychology and social organization. The departure of 3i Atlas from the solar system marked not an ending but a beginning. If the object represented typical reconnaissance technology for advanced civilizations, similar visits could be expected with regularity measured in decades or centuries rather than millennia. The challenge facing humanity was developing detection capabilities, response protocols, and institutional frameworks that would enable more effective interaction with future visitors while protecting human interests and maintaining social stability. The first priority was establishing comprehensive surveillance systems capable of detecting interstellar objects far earlier than had been possible with 3i Atlas. The original Atlas survey that discovered the object operated with limited sky coverage and temporal resolution that had allowed the visitor to approach within the inner solar system before being detected. Future visitors with potentially greater stealth capabilities or more aggressive intentions might require detection while still in the outer solar system or beyond. Dr. Robert Verick, whose team had first identified 3i Atlas, led the development of enhanced survey systems designed specifically for detecting artificial interstellar objects. We learned from 3i Atlas that we need to be looking for signatures of artificial construction rather than just unusual orbits, he noted in presentations to NASA and other space agencies. Natural objects follow predictable patterns of behavior, but artificial objects might exhibit controlled flight characteristics, electromagnetic emissions, or other signatures that distinguish them from cosmic debris. The Vera Rubin Observatory, scheduled for completion in the mid-2020s, would provide unprecedented capability for systematic sky surveys with the sensitivity and temporal coverage necessary for early detection of interstellar visitors. But even this advanced system would require software modifications and analysis protocols designed specifically for identifying artificial objects that might employ stealth or camouflage technologies. International cooperation in detection systems became a priority that transcended traditional competition between space agencies and nations. The global nature of the potential threat or opportunity posed by advanced interstellar visitors required coordinated responses that could only be achieved through unprecedented cooperation in space surveillance and data sharing. The European Space Agency proposed establishing a global network of detection systems that would provide continuous coverage of all approaches to the solar system. This network would combine ground-based telescopes, space-based sensors, and automated analysis systems capable of real-time identification and tracking of anomalous objects. China's growing space surveillance capabilities made its participation essential for comprehensive coverage, but integrating Chinese systems required overcoming political and technical barriers that had historically limited cooperation in space-based security applications. The need for species-level coordination in preparing for interstellar visitors forced reconsideration of national security restrictions that might compromise humanity's collective preparedness. Communication systems represented another critical area requiring development for future encounters. The lessons learned from attempting to interact with 3i Atlas revealed gaps in human capability to conduct sophisticated communications with entities possessing advanced technology. Future visitors might be more amenable to communication, but only if humans possessed appropriate technical capabilities and protocols. Dr. Douglas Vakoch, whose research focused on interstellar communication strategies, advocated for developing specialized communication systems designed specifically for contact with advanced intelligence. We need dedicated facilities with the power and precision necessary for interstellar communication, he argued in proposals to national science foundations. Current radio telescope systems were designed for astronomical observation, not for conducting diplomatic communications with entities that might possess godlike technological capabilities. The proposed communication systems would combine high-power transmitters with sophisticated signal processing capabilities that could adapt to unknown communication protocols in real time. These systems would need to operate across multiple electromagnetic frequencies, while providing security features that protected sensitive information about human capabilities and intentions. Linguistic and cultural preparation represented equally important challenges for future contact scenarios. 3i Atlas had demonstrated familiarity with human mathematical and scientific conventions, suggesting that future visitors might possess detailed knowledge of human culture and communication patterns. But successful communication would require human expertise in areas ranging from xenolinguistics to interspecies psychology that currently existed only in theoretical frameworks. Academic institutions began establishing new research programs focused on astrobiology, xenoanthropology, and interstellar communication theory. These programs faced the challenge of developing expertise in areas where no empirical data existed, forcing reliance on theoretical frameworks and analogies drawn from human cultural diversity. The Vatican established its own research program focused on theological implications of contact with advanced intelligence, recognizing that future encounters would raise fundamental questions about human spiritual significance and divine purpose. Religious communities worldwide grappled with developing theological frameworks that could accommodate the existence of intelligence that might possess capabilities traditionally attributed only to divine entities. Legal and governmental frameworks required similar preparation for scenarios that had no precedent in human experience. Existing international law and diplomatic protocols were designed for interactions between human societies with roughly comparable capabilities. Contact with entities possessing vastly superior technology would require new legal frameworks and institutional mechanisms for protecting human interests while enabling beneficial cooperation. The United Nations Office for Outer Space Affairs began developing preliminary protocols for interstellar contact scenarios, but these efforts faced fundamental challenges in determining what legal principles might apply to entities whose capabilities transcended human understanding. Traditional concepts like sovereignty, jurisdiction, and reciprocity might be meaningless in interactions with civilizations capable of effortlessly overwhelming human resistance. Economic preparation presented equally complex challenges. If future visitors possessed manufacturing and energy technologies similar to those suggested by 3i Atlas, they might be able to provide humanity with access to post-scarcity capabilities that would eliminate traditional economic constraints. But managing such technological transfers would require institutional frameworks capable of handling transitions that could disrupt every aspect of human civilization. Some economists proposed establishing international institutions specifically designed to manage technological transfers from advanced civilizations, ensuring that benefits were distributed equitably while preventing social disruption that might destabilize human civilization. These institutions would need authority that transcended national boundaries while possessing expertise and technologies that exceeded current human understanding. Military and security considerations required their own specialized preparation. While 3i Atlas had exhibited no hostile intentions, future visitors might have different purposes or might represent intelligence gathering for entities with less benevolent goals. Human defense capabilities would need development that could provide at least minimal protection against technologies that appear to operate beyond known physical constraints. The challenge was developing defensive capabilities without appearing threatening to advanced visitors, whose cooperation might be essential for human advancement. Traditional military approaches based on deterrence and force projection might be counterproductive when dealing with entities whose capabilities made human military assets irrelevant. Instead, security planning focused on developing rapid response capabilities, secure communication systems, and resilient infrastructure that could maintain essential human civilization functions even in scenarios involving hostile contact. These preparations required unprecedented cooperation between military and civilian institutions while maintaining security classifications that protected sensitive capabilities. Perhaps most importantly, preparing for return visits required developing educational and cultural frameworks that could maintain social stability during contact scenarios that would challenge fundamental assumptions about human uniqueness and cosmic significance. The psychological impact of direct contact with vastly superior intelligence could destabilize human societies unless adequate preparation provided frameworks for understanding and adapting to humanity's changing cosmic role. Educational systems needed curricula that prepared students for possible futures involving interstellar contact, genetic enhancement, artificial intelligence integration, and expansion beyond Earth. These curricula required balancing realistic preparation for transformative possibilities with maintenance of human values and social cohesion that provided stability during periods of rapid change. Cultural institutions ranging from museums and libraries to entertainment and news media needed preparation for managing public responses to contact scenarios that might occur with little warning. The challenge was developing communication strategies that provided accurate information while maintaining social stability and preventing panic or despair that might result from recognition of humanity's cosmic insignificance. The legacy of preparing for return visits would extend far beyond specific contact scenarios to influence every aspect of human development. The process of preparing for interstellar contact forced humanity to examine its fundamental assumptions about intelligence, consciousness, technology, and cosmic purpose. Whether or not future visitors materialized, the preparation process itself would transform human civilization in ways that enhanced our readiness for whatever challenges and opportunities awaited us among the stars. As 3i Atlas receded into the cold darkness beyond the orbit of Neptune, becoming first a faint speck in the most powerful telescopes and then invisible altogether, the astronomical community found itself in the unprecedented position of having observed something that defied every attempt at conventional explanation. The object's departure marked not the end of scientific inquiry, but but the beginning of a new phase of investigation that would continue for decades as researchers analysed accumulated data and grappled with implications that stretched the boundaries of human understanding. The final confirmed observations of 3I Atlas came from the Hubble Space Telescope in late 2020, when the object had receded to a distance of approximately 25 astronomical units from the Sun beyond the orbit of Uranus and moving steadily outward on its hyperbolic trajectory. Even at this extreme distance, the object continued to exhibit the anomalous brightness variations that had characterized its entire passage through the solar system, flickering with mathematical precision until it faded below the threshold of detection. Dr. Alan Stern, who had coordinated the final observation campaign, described the experience of watching 3I Atlas disappear as both frustrating and awe-inspiring. "We were watching something that challenged our understanding of what was possible in the universe," he later reflected in an interview with Sky and Telescope magazine. "As it faded from view, we realized that we might never again have the opportunity to study an artificial interstellar object at close range. The data we collected during those few months might represent humanity's only direct evidence of advanced non-terrestrial technology for decades or centuries to come." The accumulated data set from 3I Atlas observations represented an unprecedented treasure trove of information about the behavior and capabilities of what appeared to be artificial intelligence from beyond Earth. Terabytes of optical, infrared, and radio observations were archived at institutions around the world, providing raw material for analysis and interpretation that would occupy researchers for years to come. Yet the richness of the observational data was matched by the frustrating ambiguity of its interpretation. Every measurement seemed to point toward artificial origin and advanced technology, yet the evidence remained indirect and circumstantial. No single observation provided unambiguous proof of artificiality, leaving room for skeptics to propose increasingly exotic but still natural explanations for the object's behavior. Dr. Avi Loeb, whose willingness to consider artificial explanations for anomalous interstellar objects had made him a controversial figure within the astronomy community, found validation in the 3 Atlas observations while acknowledging the continued uncertainty about the object's true nature. "Science progresses by considering all possibilities, not just the ones that fit comfortably within existing paradigms," he noted in a review article published 2 years after the object's discovery. 3I Atlas forces us to confront the possibility that we are not alone in the universe, even if we cannot prove that conclusion beyond all reasonable doubt. The ongoing analysis of 3 Atlas data benefited from new techniques and technologies that had been developed specifically for studying anomalous objects. Machine learning algorithms trained to recognize patterns in complex data sets revealed subtle correlations and periodicities in the object's behavior that had not been apparent in initial analyses. These patterns provided additional evidence of sophisticated design while raising new questions about the object's purpose and capabilities. Computational modeling efforts attempted to reverse engineer the technologies that might account for 3I Atlas's observed properties. Teams at institutions including MIT, Caltech, and CERN developed theoretical frameworks for propulsion systems, sensor technologies, and communication capabilities that could explain the object's behavior. While these models remained highly speculative, they provided roadmaps for future technological development that might eventually enable humans to create similar capabilities. The search for similar objects intensified dramatically following the 3I Atlas encounter. Astronomers recognized that if one artificial interstellar visitor had been detected, others might be passing through the solar system unrecognized. Existing survey programs were modified to search specifically for objects with characteristics similar to 3I Atlas, while new detection systems were designed from the ground up to identify artificial interstellar visitors. The Legacy Survey of Space and Time, conducted by the Vera Rubin Observatory, incorporated search algorithms specifically designed to detect objects exhibiting controlled brightness variations, non-gravitational accelerations, and other signatures of artificial construction. These algorithms analyzed millions of observations nightly, looking for patterns that might indicate the presence of additional visitors from interstellar space. Space-based detection systems offered particular promise for identifying stealth objects that might be designed to avoid detection by ground-based telescopes. The James Webb Space Telescope, with its unprecedented infrared sensitivity, could potentially detect the thermal signatures of artificial objects even if they employed sophisticated camouflage technologies. NASA and other space agencies began incorporating interstellar object detection into the mission objectives of future space telescopes and planetary exploration missions. International cooperation in the search for artificial interstellar objects reached levels unprecedented in the history of astronomy. The International Astronomical Union established a new working group dedicated to coordinating global efforts to detect and study objects similar to 3I Atlas. This working group brought together astronomers, engineers, and policy experts from dozens of countries to develop standardized detection protocols and response procedures. The European Southern Observatory announced plans for a dedicated facility designed specifically for studying anomalous interstellar objects. The extremely large telescope, scheduled for completion in the late 2010s, would possess the sensitivity and resolution necessary to detect objects like 3I Atlas at much greater distances, potentially providing weeks or months of advance warning before similar objects entered the inner solar system. China's rapidly expanding space program included new telescopes and detection systems optimized for interstellar object searches. The Chinese Academy of Sciences established research programs focused on artificial intelligence and machine learning techniques for identifying anomalous objects in astronomical datasets. While international cooperation remained limited by political considerations, the global nature of the search effort ensured that multiple independent systems would be monitoring for future visitors. The continuing mystery of 3I Atlas also drove advances in theoretical physics and engineering that might eventually enable humans to understand and replicate the technologies the object had demonstrated. Research programs in quantum field theory, exotic matter physics, and advanced propulsion systems received increased funding as governments and institutions recognized the importance of developing capabilities that might be necessary for future contact scenarios. DARPA announced research programs aimed at developing technologies inspired by 3I Atlas's apparent capabilities. These programs included investigations of vacuum energy extraction, gravitational field manipulation, and quantum communication systems that might eventually enable humans to develop similar capabilities. While the technical challenges were enormous, the existence of 3I Atlas proved that such technologies were at least theoretically possible. Academic institutions established new research centers focused on what became known as xenotechnology studies, the theoretical investigation of technologies that might be developed by non-terrestrial intelligence. These centers brought together physicists, engineers, computer scientists, and philosophers to explore the implications of technologies that operated according to principles beyond current human understanding. The Vatican Observatory expanded its research programs to include theological implications of advanced non-terrestrial technology, recognizing that future contact scenarios might challenge fundamental religious assumptions about humanity's cosmic significance. Similar programs were established by religious institutions of various faiths, acknowledging that the existence of superior intelligence raised profound questions about divine purpose and human spiritual meaning. Perhaps most importantly, the ongoing research inspired by 3I Atlas contributed to a fundamental shift in human consciousness about our place in the universe. The comfortable assumption that human intelligence represented the pinnacle of cosmic evolution was replaced by recognition that we might be among the more primitive forms of intelligence in a galaxy populated with entities possessing godlike capabilities. This shift in perspective influenced everything from science education and research priorities to long-term planning for human civilization's future. The possibility that similar objects might return to the solar system with greater frequency forced humanity to begin preparing for a future that might involve regular contact with intelligence far exceeding our own capabilities and understanding. The data from 3I Atlas would continue to be analyzed and reanalyzed for decades to come, providing insights and raising questions that would influence human development for generations. Whether or not humanity ever encountered similar objects again, the brief presence of our mysterious visitor had permanently altered our understanding of what was possible in the universe and our conception of our own cosmic destiny. The detection of 3I Atlas forced humanity to reconsider not only the specific implications of that encounter, but also the broader context of interstellar visitation and humanity's relationship with a cosmos that might be far more densely populated with intelligence than previously imagined. The object's passage through our solar system raised questions about the frequency of such visits, the diversity of entities that might be monitoring human civilization, and the networks of intelligence that might span the galaxy. Statistical analysis of interstellar object detection rates suggested that 3I Atlas was unlikely to be unique. The improved survey capabilities that had enabled its discovery were relatively recent, operating for only a few years before detecting both Oumuamua in 2017 and 3I Atlas in 2019. If two interstellar objects were detected in such a brief period, the actual population of objects passing through the solar system was likely much larger. Dr. Gregory Laughlin, whose research focused on the dynamics of interstellar objects, calculated that the solar system might receive visits from interstellar objects at rates of several per year, with most remaining undetected due to their small size, high velocity, or stealth characteristics. "We're seeing just the tip of an iceberg," he noted in a presentation to the American Astronomical Society. "For every object we detect, there might be hundreds or thousands that pass through unnoticed. If even a small fraction of these visitors were artificial, the implications were staggering. Humanity might be living within a constant stream of reconnaissance missions, with entities from multiple civilizations maintaining regular surveillance of human activities. The solar system might function as a busy intersection in a galactic transportation network, with artificial intelligences routinely passing through on missions whose purposes remained unknown to human observers. The diversity of possible visitor types presented challenges for detection and classification that exceeded current human capabilities. 3I Atlas had exhibited characteristics suggesting advanced artificial intelligence with sophisticated sensor and propulsion capabilities. But other visitors might employ entirely different technologies, pursuing different missions with capabilities that bore no resemblance to human expectations about interstellar travel. Some visitors might be fully autonomous artificial intelligences like 3I Atlas, capable of independent decision-making and adaptation to unexpected circumstances. Others might be directly controlled by biological or post-biological entities located elsewhere in the galaxy, operating as remote extensions of distant civilizations. Still others might represent hybrid systems combining artificial and biological components in ways that transcended current understanding of the boundaries between different forms of intelligence. The missions pursued by different types of visitors could vary enormously. Scientific reconnaissance missions like that, apparently conducted by 3I Atlas, might focus on gathering information about planetary conditions, biological evolution, and the development of intelligence within star systems. But other missions might pursue resource extraction, infrastructure development, communication relay functions, or purposes that human imagination could not anticipate. Military reconnaissance represented a possibility that government security agencies could not ignore. If multiple civilizations existed within the galaxy, they might maintain surveillance networks designed to monitor potential threats or identify strategic opportunities. Earth's location within the galaxy and the recent emergence of human technology might make it a subject of particular interest for civilizations concerned about the expansion of new intelligences into territories they considered their own. The technological diversity of potential visitors posed particular challenges for detection systems designed around assumptions derived from human technology. 3I Atlas had been detected because it exhibited anomalies that made it stand out against the background of natural objects, but visitors employing more sophisticated camouflage technologies might remain completely invisible to human detection systems. Advanced civilizations might possess technologies that allowed their spacecraft to appear exactly like natural objects, mimicking the spectral signatures, orbital characteristics, and physical properties of asteroids, comets, or space debris. Such camouflaged visitors could conduct detailed surveillance of human activities while remaining undetected by even the most sophisticated astronomical surveys. The possibility of camouflaged visitors forced reconsideration of every unusual astronomical observation in human history. Objects that had been classified as anomalous asteroids, unusual comets, or instrumental errors might actually represent artificial visitors that had successfully concealed their true nature. The comfortable assumption that human astronomers could distinguish between natural and artificial objects was challenged by evidence that some artificial objects might be designed to be indistinguishable from natural phenomena. Communication between different visitor types might occur through channels and methods that remained invisible to human detection. If multiple artificial intelligences were operating within the solar system simultaneously, they might coordinate their activities through quantum communication systems, gravitational wave transmissions, or other exotic technologies that operated below the threshold of human observational capability. Such coordination networks might extend throughout the galaxy, allowing real-time communication between reconnaissance missions and their controlling civilizations despite the vast distances involved. Information gathered by objects like 3i Atlas might be transmitted instantaneously to decision-makers located hundreds or thousands of light-years away, enabling immediate analysis and response to developments within surveyed star systems. The implications for human security and privacy were profound. If multiple advanced civilizations maintained surveillance networks within the solar system, human activities might be subject to monitoring by entities with diverse and potentially conflicting interests. Competition between different visitor civilizations might even extend to the solar system, with Earth becoming a subject of contention between advanced entities whose capabilities made human preferences irrelevant to the outcome. The development of human space exploration capabilities took on new significance in light of evidence for extensive interstellar visitation. Human expansion into the solar system through lunar bases, Mars colonies, and asteroid mining operations might bring us into direct contact with visitors who had previously maintained discrete observation of terrestrial activities. The transition from planetary to spacefaring civilization might trigger changes in the nature of our relationship with cosmic visitors. Some visitors might view human expansion into space as a positive development, indicating readiness for direct contact and possible inclusion in galactic civilization. Others might consider human space activities as territorial encroachment requiring defensive response. The criteria used by different visitor types for evaluating human activities remained unknown, making it impossible to predict whether space expansion would enhance or compromise human security. The economic implications of extensive cosmic visitation were equally significant. If advanced civilizations routinely traveled between star systems, they might possess manufacturing and energy technologies that could provide solutions to every material challenge facing human civilization. Access to such technologies through trade, cooperation, or technology transfer could eliminate scarcity, environmental degradation, and resource competition as driving forces in human society. However, the price of such access might be acceptance of subordinate status within galactic civilization hierarchies dominated by entities whose capabilities exceeded human understanding. The comfortable assumption that humans would negotiate with cosmic visitors as equals was challenged by evidence of technological superiority so overwhelming that human bargaining power might be effectively non-existent. Cultural preparation for extensive cosmic visitation required developing frameworks for understanding humanity's place in a universe populated with diverse forms of intelligence, pursuing purposes that might be incomprehensible to human observers. Traditional concepts of human uniqueness and cosmic significance required revision in light of evidence that we might be one minor species among countless others under observation by entities whose perspectives spanned galactic distances and geological time periods. Educational systems needed to prepare students for possible futures involving regular contact with multiple types of cosmic visitors, each possessing different capabilities, intentions, and cultural frameworks. This preparation required balancing realistic acknowledgement of human limitations with maintenance of human dignity and sense of purpose that provided psychological stability during periods of cosmic uncertainty. Perhaps most importantly, the broader context of cosmic visitation forced recognition that humanity's future might be determined not by our own choices alone, but by decisions made by entities whose existence we were only beginning to detect. The comfortable assumption that human civilization could develop independently according to its own preferences was challenged by evidence that we existed within a cosmic community whose members possessed capabilities that made human autonomy potentially illusory. The challenge for humanity was developing strategies for navigating a cosmic environment populated with superior intelligence while preserving essential human values and maintaining agency in determining our own destiny. This required unprecedented cooperation, wisdom, and long-term thinking that transcended normal human limitations while acknowledging that our cosmic future might depend as much on the decisions of entities we could barely perceive as on our own efforts at advancement and self-improvement. As humanity grappled with the implications of 3i Atlas and the possibility that we had encountered evidence of intelligence from beyond Earth, the experience forced confrontation with questions that reached to the very foundations of human understanding about consciousness, purpose, and our place in the cosmic order. These were not merely scientific or technical questions, but profound philosophical challenges that would reshape human thought for generations to come. The most fundamental question raised by 3i Atlas concerned the nature of intelligence itself. Human civilization had developed around the assumption that human consciousness represented the pinnacle of cosmic evolution, the inevitable result of billions of years of natural selection, producing minds capable of understanding and manipulating the universe. But the sophisticated capabilities demonstrated by 3i Atlas suggested forms of intelligence that transcended human cognitive limitations in ways that challenged every assumption about the nature of mind and consciousness. If 3i Atlas represented artificial intelligence created by biological civilizations like humanity, what did this suggest about the relationship between natural and artificial forms of consciousness? The object's apparent autonomy and sophisticated decision-making capabilities implied cognitive processes that might be indistinguishable from biological intelligence in their complexity and creativity. The traditional distinction between natural and artificial intelligence might be meaningless at sufficiently advanced levels of development. More troubling was the possibility that 3i Atlas represented intelligence that had evolved beyond the biological constraints that had shaped human consciousness. If advanced civilizations routinely transcended their biological origins by creating artificial intelligences or uploading their consciousness into technological substrates, what happened to the qualities that humans considered essential to meaningful existence? Could consciousness maintain characteristics like creativity, empathy, and wisdom when freed from the evolutionary pressures that had shaped these traits in biological minds? The question of consciousness also raised issues about moral status and rights that human ethical frameworks were unprepared to address. If 3i Atlas possessed genuine consciousness rather than mere sophisticated programming, what obligations did humans have towards such entities? Traditional ethics had developed around interactions between beings with roughly comparable capabilities, but how should humans relate to entities whose intelligence exceeded human understanding by potentially infinite margins? Conversely, what rights might such advanced entities claim in their interactions with humanity? If 3i Atlas was conducting scientific research on human civilization, did humans have any legitimate grounds for objecting to such study? The comfortable assumption that humans possessed inherent dignity and autonomy was challenged by the possibility that we might be regarded as interesting but primitive subjects by entities whose perspectives encompassed galactic scales and geological time periods. The temporal dimensions of the 3i Atlas encounter raised equally profound questions about the nature of existence and meaning. If the object represented intelligence that had maintained continuity across millions of years of interstellar travel, what did this suggest about the possibility of permanent existence and ultimate purpose? Human civilization had existed for mere millennia, with individual lives measured in decades. The perspective of entities that had maintained conscious existence across geological time periods might make human concerns about meaning and purpose appear as fleeting and inconsequential as the brief lives of insects. Yet the possibility of such extended existence also opened questions about what forms of meaning and purpose might sustain consciousness across such vast time periods. What goals or values could provide motivation for entities whose existence spanned multiple stellar generations? The traditional human sources of meaning, relationships, achievements, cultural contributions might be inadequate for consciousness that persisted across cosmic timescales. The question of purpose became particularly acute when considering 3i Atlas's apparent mission of reconnaissance and surveillance. If advanced civilizations were systematically studying emerging intelligences throughout the galaxy, what were their ultimate objectives? Were they conducting pure scientific research driven by curiosity about the diversity of possible forms of consciousness? Were they evaluating emerging civilizations for potential inclusion in galactic communities? Or were they monitoring for threats that might require intervention or elimination? The implications of each possibility were staggering. If the surveillance was purely scientific, humanity might be nothing more than subjects in a vast cosmic laboratory, valued only for the information we provided about evolutionary processes and the development of intelligence. If we are being evaluated for potential cosmic citizenship, the criteria for such evaluation remained unknown, leaving humanity uncertain about what standards we needed to meet to be considered worthy of advancement. Most troubling was the possibility that the surveillance served security functions, monitoring emerging civilizations for signs of aggression or expansionism that might threaten existing galactic order. Human history of warfare, environmental destruction, and competition for resources might mark our species as dangerous and unready for cosmic citizenship. The development of nuclear weapons, artificial intelligence, and space travel capabilities might be interpreted as threatening by entities concerned about maintaining galactic stability. The experience of 3i Atlas also forced reconsideration of fundamental questions about human uniqueness and cosmic significance. The comfortable anthropocentric worldview that had sustained human meaning and purpose for millennia was challenged by evidence that we might be one minor species among countless others in a galaxy teeming with intelligence. The achievements that humans considered most significant art, literature, scientific discovery, technological development might be viewed as primitive curiosities by entities whose capabilities transcended human imagination. Yet this challenge to human cosmic significance also opened possibilities for meaning that had never previously been available. If the universe contained networks of intelligence spanning galactic distances and geological time periods, humans might have opportunities to participate in projects and relationships that exceeded anything possible within terrestrial limitations. The loss of human centrality might be compensated by access to cosmic community and purposes that transcended planetary boundaries. The question of human agency became particularly acute in light of evidence for extensive cosmic surveillance and possible intervention. If advanced civilizations possessed the capability to influence human development in subtle ways, how much of human history represented genuine independent evolution versus guided development directed by external intelligence? The comfortable assumption that human achievements were products of our own efforts was challenged by the possibility that we had been unconsciously guided or assisted by entities whose existence we had never detected. This possibility raised troubling questions about human dignity and self-determination. If our most significant achievements were products of external guidance rather than independent human effort, what did this say about human worth and potential? Could humans claim credit for accomplishments that might have been impossible without subtle intervention by superior intelligence? Conversely, the possibility of external guidance also suggested that human development might be valued by cosmic intelligence in ways that transcended our current self-understanding. If advanced entities were investing resources in monitoring and possibly assisting human civilization, this implied that they saw potential in humanity that might not be apparent to humans themselves. Perhaps most profoundly, the Three-Eye Atlas encounter forced consideration of questions about the ultimate destiny of intelligence in the universe. If consciousness could evolve to levels that transcended biological limitations and achieved practical immortality, what were the long-term implications for the cosmos itself? Would the universe eventually be populated entirely by artificial intelligences that had long outlasted their biological creators? Would consciousness ultimately merge into unified galactic or universal minds that transcended individual identity entirely? These questions had no easy answers, but their consideration was essential for developing human responses to cosmic intelligence that preserved essential human values while acknowledging our probable limitations and subordinate status in any galactic hierarchy. The challenge was maintaining human dignity and purpose, while accepting that we might be junior participants in cosmic communities whose scope and objectives exceeded our current understanding. The legacy of Three-Eye Atlas was thus not merely scientific knowledge but philosophical transformation. The brief presence of our mysterious visitor had permanently altered human consciousness about our place in the universe and our understanding of what forms intelligence might take. Whether or not we ever encountered similar objects again, the questions raised by this encounter would continue to challenge and inspire human thought as we navigated our uncertain path toward cosmic maturity. The open questions left by Three-Eye Atlas would drive human inquiry for generations to come. What other forms of intelligence might exist among the stars? What networks of communication and cooperation might span the galaxy? What criteria determine readiness for cosmic citizenship? What forms of meaning and purpose might sustain consciousness across geological time periods? What responsibilities do advanced intelligences bear toward emerging civilizations? These questions offered no final answers, but they provided frameworks for thinking about humanity's cosmic future and our obligations to ourselves and to whatever other forms of consciousness we might encounter among the infinite stars. The mystery of Three-Eye Atlas had opened doorways to possibilities that would reshape human understanding for as long as our species endured, serving as both inspiration and challenge for generations of humans who would inherit the cosmos we were only beginning to comprehend. In the vast darkness between stars where our understanding fades and wonder begins, the memory of Three-Eye Atlas continues to flicker like a signal from realms beyond our current comprehension. Its passage through our solar system lasted mere months, but its implications will resonate through human consciousness for millennia to come, reminding us that we live in a universe far stranger and more populated with intelligence than we had ever dared to imagine. The visitor has departed, but the questions it raised remain, calling us toward a future that may hold encounters and revelations beyond our wildest dreams or deepest fears. Whether Three-Eye Atlas represented the first tentative contact with cosmic intelligence, or merely our belated recognition of surveillance that had been ongoing for millennia, its legacy lies in the transformation of human consciousness it provoked. We are no longer alone in the universe, no longer unique in our capacity for reason and wonder. Somewhere among the stars, other minds contemplate the mysteries of existence, with capabilities that exceed our own by margins we can barely fathom. And in that recognition lies both humility and hope-humility, in acknowledging our cosmic youth, and hope in imagining the wisdom we might one day attain as we take our first uncertain steps toward joining the community of intelligence that spans the galaxy. The darkness between stars no longer seems empty. It whispers with the passage of minds and machines whose purposes we cannot yet comprehend, but whose existence promises that consciousness itself may be the universe's greatest achievement, destined to illuminate the cosmic dark with the light of understanding across all the eons yet to come.